Okay, let's start. So today we'll study about the chapter 6. Chapter 6, it is sinusoidal and phasors we have to study. What we study in this is, we no, I will upload today. Sinusoids we will study what is exactly how it behaves, sine, cosine, sinusoids, how it will behave. We will study that one. What are the phasor equations, sinusoidal equations, how to, what is the lag and what is the delay, we will study that one. What is the time period, frequency, we will study. Now, then we'll study to phasors. Then we'll study to phasor relationship for circuits, for our circuits, like how it can be related to our circuits, Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, how these are related. Because now we are dealing with the AC supply. Power supply is AC. So we need to know what is sinusoid, what is the phasors. Then we can go for the circuits. Last we'll study impedance and admittance. So generally we call resistance in the DC circuits. In AC circuits, because inductance and capacitance effect will come due to the AC, we call that resistance as a impedance. The conductance will called as a admittance. So these we will study in this. Then we have summary, some examples we have, problems we will study. So today I will finish the sinusoids. In next class, phasors and the relationship for circuits. In another class, impedance and admittance. 3 classes it will finish, inshallah. So first come to the what is sinusoids. In this chapter we are particularly interested in sinusoidal time varying excitation. Means due to the change in time, how the voltage currents will vary, we will study. Or simply excitation by sinusoid. A sinusoid is a signal that has form of sine or cosine function. You know that DC, direct current, means the constant, no change with the time. But with alternating current or alternating voltage is nothing but it is time varying with the amplitude. Means time varying amplitude will be there. So that in the form of sine or cosine it will be there. So how it will be, we will see. A sinusoidal current is usually referred to alternating current. So AC current also known as sinusoidal current. Both are same. We are interested in sinusoid for few reasons. Why we go for sinusoid? Why not always direct current? So sinusoid, why we have to study? Nature itself is a characteristically sinusoidal. So nature itself means biological. If we say sound waves, you say our tidal waves. How the tidal waves are? Sine wave. When the tides coming in the water, the bahar, it will come as a sine waves. So that's called the sinusoidal, we'll say, waves. Now, biological cycle, morning, evening, day, night, all biological cycles are, some cycle is there. So that's why it's called cyclic. Periodically we can say, cyclic we can say. So that's why we go with the sinusoids. A sinusoidal signal is very is easy to generate and transmit. So your radio frequency or optics, all are sinusoidal. We can generate easily. We can transmit for far distances also. Another one, through Fourier analysis. This we will study in another subject. The Fourier analysis. Any practical periodic signal can be represented by a sum of sinusoid. Means 2 or 3 sinusoid symbols. What we call functions can be reproduced by Fourier analysis. Practically, we can explain that one, how this is behaving. So now come what is sinusoid, we'll study. Now see this diagram. What you are observing here? In this diagram, you are observing on the y-axis, that is voltage, which is having Vm maximum, that is maximum voltage, and minus Vm, the negative maximum voltage. Now on the x-axis we have time period, generally we call omega t time period. This is the time cycle. So if you observe the cycle, one is the half cycle with the varying from 0 to maximum value and maximum value to 0. It is varying. Now from this point up to pi in radians per second. We will see what is the pi there later. Now from this point 0 to minus Vm and minus Vm to 0, it is continuing to up to 2 pi. From this 2 pi to 3 pi, again what is there in 0 to pi, it is repeating. Now from 3 pi to 4 pi, what is there in pi to 2 pi, it is repeating. Like this, the cycle will continuous. So by just observing the waveform, how can we write a mathematical equation for this waveform? Can anyone? Let us take Vm is the amplitude for this wave. What is the maximum value? Plus or minus Vm. So I can put in the equation Vm as it is. Now how the waveform is behaving, in which trigonometric function it is behaving, sine or cosine? Sine, because it's starting from 0, it is sine. If it's starting from 90 degrees, then it is cosine. So it is starting from 0. So it is behaving a sine term. So sine function we can say. So Vm I can write, then we can write sine, and how it is varying with respect to omega t. With respect to omega t. So sine theta should be there. The theta I am replacing with omega t. So at a particular omega t, you will get the particular value. Like omega t at omega t is equal to pi. What is the pi value? 180 degrees, right? So Vm sine 180 degrees. What is Vm sine 180 degrees? What is sine 180 degrees? 0. 0 multiplied by Vm, 0. So is matching here. Vm sine omega t is matching. Correct. Now at the point of here, let us take here exact Vm is maximum 90 degrees it is, right? Pi by 2. So Vm sine 90 degrees. What is sine 90 degrees? 1. So Vm multiplied by 1 Vm. So Vm is there here, maximum is Vm. So like this we are proving that our equation is correct. What is the equation? Vm, this is the Vm, voltage Vm multiplied by sine omega t, sine omega t. Okay. So we can write V of t voltage is nothing but Vm sine omega t, where Vm is the amplitude of the sinusoid, amplitude of the sinusoid. Then omega, what is omega here? Inside two terms are there, omega and t. So omega is the angular frequency, okay, it may be in radians per second or in degrees if you substitute in the sign, depends, later it will discuss that one. So angular frequency radians per second. Now omega t jama, that is together is called argument of the sinusoid, means the complete argument of the sinusoid, like sine theta, sine A, sine B, the argument inside what is there. So that is the argument of the sinusoid is omega t. Now observe another waveform. Now in this waveform, you can see here I just replaced pi, 2 pi, 3 pi, 4 pi with t by 2, capital T by 2, capital T, and 3t by 2, 2t. So what I am doing? Half cycle I am using as t by 2. Then another half cycle, that is we call full cycle we can say. That is t, means time period, capital T we can say. Capital T is one time period which have the half cycle positive, half cycle negative. Like this it is continuing. 3t by 2. Just add t by 2 here. T plus t by 2, how much? 3t by 2. Then add again t by 2 here. It become 4t by 2. It is 2t. Like this it will go. But here observe. Here omega t is the your time function. Here only t is there. Okay, omega t is the time function. Now here I change to t, time period t, only in seconds. Here angular frequency radians per second multiplied by time. So just it's coming radians only. But here in seconds only, no change, no radians, nothing. In seconds. Okay. Now t by 2 should be in seconds. T in seconds. All are in seconds only. Now compare these two and write the equation. Pi and let's say 2 pi. At 2 pi equal to t. Can I write 2 pi equal to t? Yes or no? Because I just rearrange pi with t by 2. 2 pi with t. Can I write 2 pi equal to t? 2 pi is equal to capital T. Can I write or not? No, check once again here. Check what is here, omega t. Check what is here, t. So can I write directly 2 pi is equal to t? Yes or no? Yes. Yes, but partially yes, not complete yes. Why? Because here what is the time period? Omega t. Now here t. I can equate it, but something is missing here. What is missing here? Omega is missing here. So divide this omega everywhere here. Everywhere you divide this omega, pi by omega, 2 pi by omega, 3 pi by omega, 4 pi by omega. Then it become t here. It become only t. So here also t is there. Now equation is correct. Now t become 2 pi by omega. Understand here my point? Here omega t is there. So just make this pi with take this omega pi with, I want to make this only in t. So what I have to do? Pi divided by 2. Here, omega. Pi divided by omega. Now here 2 pi in the second time by omega. 3 pi omega. Like this it will go. Now here t is matching, here t is matching. Okay. Now I just replace pi with t by 2. I replace 2 pi with capital T. Then this t will become how much? 2 pi by omega. Now it is matching. You cannot say directly 2 pi is equal to t because that axis is not matching. Omega t is there, here t is there. So that's the problem. Okay. So like this, t is now the time period is equal to 2 pi by. It will come here, no problem. Okay, see here. It is evident that the sinusoid repeats itself every t seconds. That's why every t seconds it is repeating. Half cycle positive, half cycle negative. Thus, t is called the period of a sinusoid. Means one period of a sinusoid is nothing but capital T. Now, from the plot 9.1, from this plot, we can observe that omega t is nothing but 2 pi. From these two plots also we can say omega t is nothing but 2 pi. Now, capital T is nothing but 2 pi by omega. So, t is nothing but 2 pi by omega. Here directly he gave equation, but I explained how it is coming. Okay. So t is always, you have to remember, any problems, small problems or multiple choice problems also will be there. There you need this one. T is equal to 2 pi by omega. You have to remember. Any conversion is required this one. T is equal to 2 pi by omega. Now coming to the fact v of t, the sinusoid, repeats itself every t seconds. We know. Yes, no half cycle, jama capital T. It repeats that one. 2t, 3t, 4t, repeats it. Now let us take, I will replace this t, v of t, this v of t inside a particular time t with t plus t, means one cycle more. What is capital T? One cycle, right? T plus time period, one cycle. So t plus t in the previous equation, let us take. What it become? V of t plus t is becoming Vm sin omega t, it was there. Now it become t plus capital T. Previously it was sin omega t. Now I replace this t with t plus capital T. So here also t plus capital T will come. Now Vm sin omega t, multiply in that t plus what is capital T? Just now we had in terms of this one omega and 2 pi. It is 2 pi by omega. Just resubstitute this one. What is capital T from the previous slide? Substitute 2 pi by omega. Now Vm sin omega t, this one, multiply this omega inside. So what it become? Omega and t will become, and omega will cancel here, become only 2 pi. So omega t plus 2 pi will remain. So this become now Vm sin omega t plus 2 pi. Now this equation Vm sin omega t plus 2 pi can be written as Vm sin omega t. What happened to this 2 pi? This 2 pi was there now. See here, Vm sin omega t plus 2 pi was there. Now I am telling that this becomes Vm sin omega t.
Sin 2 pi means 0?
Yes, but how? How it is becoming 0 and why it is only coming this one? I will tell. How this look like this form? Sin A plus B. In this form of sin A plus B. Trigonometric equation I am telling. Sin A plus B. What is sin A plus B in the general equation?
A plus B.
Sin of A plus B. What is the equation? Sin A cos B plus cos A sin B. Sin A plus or minus B is nothing but sin A cos B, cos A sin B. If it is cos A plus or minus B, then it is cos A cos B minus or plus, that is sin A sin B. This is different. Okay. So you can rearrange this one. Sin AB. This is A. Omega t is A and B is 2 pi. Now substitute here. Sin A. How much? Omega t. Cos B. How much? B. B. What is B? 2 pi. Cos 2 pi. Cos 360 or cos 0. What is cos 0?
No, cosine 2 pi.
Yeah, cosine. Cosine 2 pi or cosine 0. Same. What is the value?
Minus, no.
1. So sin omega t here sin A means sin omega t multiplied by Wahed. So sin omega t. Now here this term cos A. What is cos A? Omega t. Cos omega t. Sin B. What is B? Sin 0. What are 360? Sin 0. How much? 0. So multiply something to 0. 0. So what remains here? 1 multiplied by sin omega t. So we are getting sin omega t here. Same. So how we are getting? I am just writing here. Okay. So see sin omega t plus 2 pi, which is nothing but sin A cos B, sin omega t cos 2 pi plus cos A sin B cos omega t sin 2 pi. So sin omega t multiplied by 1 because of the cos 2 pi, cos omega t multiplied by 0 because of the sin 2 pi. So you will get only sin omega t. So we can write V of t plus capital T is nothing but Vm sin omega t. Means for any time periods, 2t, 3t, 4t, 5t, whatever you write, you result in only Vm sin omega t only. Okay, it won't change. The result will be same. Maybe first cycle, what is the value? Same. Second cycle means 2 cycles, same. 3 cycles, same. It won't change, that it is proving. Okay. Hence, V of t plus t is nothing but V of t. And general equation also we can write here. Thus, V has the same value at t plus t as it does at t and V of t is said to be periodic. That's why we call, because it is same for every cycle, it is called a periodic. Every period same. So that's it's a periodic. The definition is proving this now. Now again, definition, complete definition we can write. A periodic function is one that satisfies function at time t, which is function at time t plus n capital T time period for all time t for all integers n. Now substitute here integer n here. Integers will be 1, 2, 3, 0, 1, 2, 3, right? Any number. Substitute any number here, 0 to infinity. The result will be same, Vm sin omega t only. So it is a periodic function. It's a periodic result. So understand this one, why we are going for periodic. Then we go for phasor, because without understanding why the sign is there in every cycle, why it is not changing. So we have to understand. Okay, the period t, one cycle, the period t of the periodic function is the time of one complete cycle or number of seconds per cycle. Means we already converted this omega t to t, small t. So what is small t? It is seconds. Small t is nothing but seconds, number of seconds it is, Tanya. So what it is telling, it is a complete cycles or number of seconds per cycle. Means for one cycle, cycle and nus cycle jama, one cycle, how many seconds? That is called period t, or we can also say time period t also we can say. The reciprocal of this quantity, if you reverse this one, 1 divided by t is nothing but, it is number of cycle, number of seconds per cycle. Now if you reverse this one, number of thaniya per Wahed cycle, one cycle, it is the t. Now I want to reverse this one. What happened? One cycle per thaniya, right? Here number of thaniya per cycle was there, right? Now if you reverse this one, cycle will come up, thaniya will go down. So up will be one cycle, down will be in one time, 1 second, and above will be number of cycles. That's number will not change. Cycles and time will change here. So that is called as cyclic frequency. How it is repeating fast, how fast it is going. That is called frequency. Frequency means how frequent. How frequent is moving, positive to negative, positive to negative. How frequent. That's why it is called frequency. So that's given by f is equal to 1 by t. Now you tell me what is t actually in terms of radians, 2 pi and omega. What is capital T in 2 pi and omega? It is 2 pi by 2 pi taksim omega. Now substitute here 2 pi taksim omega. Now it becomes omega by 2 pi. So now we know that t is equal to 2 pi by omega. Now rearrange this one. Then it will become omega is equal to 2 pi f. How? Now substitute t in terms of f. What is f? 1 by f here. Put t is equal to 1 divided by f here. Okay? And f to this side. and omega this side. So omega is equal to 2 pi f. 2 pi zarb f. This is how we rearrange this one. You will get omega is equal to 2 pi f. So this is called, there omega is in radians per second and f is in hertz. The frequency always units is hertz, we say. Okay. And if you remove the z here, what is the remain here? H. Can I use H here for hertz? Single letter? No. Why? The capital H is Henry. That is inductance unit. So I cannot use that one. That's why he added Z there here. So hertz. Okay. Now see this waveform, how it look like. Now just now what we finished in 2 or 3 slides previously with single waveform. Right? Sinusoid, one waveform. This one. Vm omega, Vm sin omega t. Vm sin omega t. This one we studied. Just now, what we studied, pi, 2 pi, omega t, same thing, nothing changed. Now what I am doing is, I am adding another waveform, this one, no, another waveform I am adding into the same, what we call plot, that I am telling, this is the V1, which is equal to Vm sin omega t. Now this waveform, which is starting 5 degrees previous, 5 degrees previous from the 0. So I can write this waveform as, based upon this, the reference waveform with the 0 as Vm sin omega t plus 5. How much difference we have from 0 to this waveform starting? 5. So I have to add that amount. So that's why it is Vm sin omega t plus 5. So do you understand? The V1 is Vm sin omega t because it is starting from 0. No problem. The second waveform also starting from 0. But it is already started. When it started? 5 degrees or something 5 amount previous. So add something. So add with omega t plus 5, some angle, some degrees we can say. So this is how we have two waveforms. Now we have V1 and V2. Let's see. Let us now consider a more general expression for the sinusoidal. How? V of t, this equation is nothing but Vm sin omega t plus 5. General equation we call Vm equal to sin V of t is equal to Vm sin omega t plus 5. If phi is 0, means there is no difference, then it is 0. So it becomes V1, Vm sin omega t. If there is a difference, or it is going, previously it is starting plus y. It is starting afterwards. If this waveform is starting from here, let us take, then it is minus 5, means lagging. Then this is first, here plus 5, it is leading. Reference always V1. Reference is always V1, which is starting from 0. Which is starting from 0 is the reference point. The remaining waveforms is the lagging or leading, we say. Means, what we call lag and lead in Arabic? Takhir and khiyada. So, khiyada hada plus 5. Takhir hada minus 5 will come. Okay? Plus minus it will change. Now it will see. Now, where omega t plus 5 is the argument of the sine. Sine argument is nothing but yours omega t plus 5. And what is phi? Phi is called phase. How much phase? How much takhir? How much? What do you call?
Leading on
Anything. Takhir and also. What's aks?
leading
Khiyadam. Khiyada. So, phi is the phase. Takhir or khiyada. Okay? Takhir means plus 5. Khiyada minus 5. So both argument and phase can be in radians or degrees. You can rearrange it with radians or degrees. Sine will take care of that one. Okay, now let us examine two sinusoids, V1 and V2. So V1 of t is nothing but Vm sin omega t. And V2 of t is nothing but Vm sin omega t plus 5. Okay, so now the starting point of V2, where this is the V2, starting point of V2 occurs first in time. This is okay, we are assuming this is a 0, but it is occurred before the time only, right? So occurs first in time, before the time only. So that's why we say V2 leads V1, khiyada, okay, by 5 degrees, or V1 takhir lags V2, we say, by 5 degrees. So two words are there, lead and lag is very important. Plus 5 lag, sorry, plus 5 lead, minus 5 it is lag. Or you don't want to use plus or minus in that, you can use terminology lag, lead and lag. You can change the term voltage 1 and 2. voltage 1 is lag with voltage 2. Angle is same, plus minus maafi there, okay? And V2 leads V1 by that phase, fine. So like this, if you use the word lag and lead, no plus minus. Okay, if you are using minus and plus, then we have to tell with the same terminology V1 with minus 5 degrees ahead, or this one minus 5 degrees. We can use only one term, lag or lead with plus minus.
Plus related to lags?
No, it is slight confusing. I will tell. If you are using reference with V1, because it's starting from 0, right? Now we are using the reference with the V1. Now you can use plus minus with lag. Okay, V1 lags V2 with 30 degrees. Okay, but I don't want to change the V1. I want to change I want to use V1 only. Then we can use V1 leads. No, V1 lags with minus 5 phase degrees with V2. Minus you can use there. If we are putting V1 as a reference only, I don't want to change the V1, V2 again. That's the important here. The two terminologies are there. Anyone you can use. Okay, if we have two conditions here. If phi is not equal to 0, we also say V2 and V1 are out of phase. They are out of phase. Now let us check two cars are moving with 120 speed. I know you maintain that one. 120 speed kilometer per hour. If both are maintaining same, then what we will say? Oh, they are parallel, same phase, same pitch they are going, right? It is the same phase. If one car is moving ahead, then we have to tell first car is leading the second car. Okay? That's like leading the second car. If first car is moving 130 kilometers per hour and second car is moving 120 kilometers per hour. So which is in front? First car. So first car leading with the second car. If you change in terminology, second car is lagging with the first car. So like this, and that will happen when phi is not equal to 0, and that is called out of phase. They are not in the same phase. They are out of phase. Up down is called out of phase. Now, if phi is equal to 0, same speed, they are maintaining both, then it is called in phase. Both are starting and ending at same point. It is called in phase. Okay. Now next come to a sinusoid can be expressed in either sine or cosine form. Now whatever till now is explained is sine term because we start from 0, right? The cosine term will start from 1, and generally if you take in the angle 90 degrees. Sine 90 degrees is nothing but cosine. They will say in the angular form I will show. When comparing two sinusoids, it is expedient to express both as either sine or cosine with positive amplitude. If I want to draw or compare within a graph, then first you have to assume both are positive amplitude. Vm is positive. But cosine, sine inside angle how much? Then we will decide. That will decide it is lagging, leading, how much it will decide. Check here. This is cos, always on the horizontal term because cos 0 is 1. Right? Okay. Then sine, it will be on the 90 degrees, minus 90 degrees. Always sine minus 90 degrees, this one. So this is actual graph in trigonometry. Cos and sine will be on the x-axis, cos will be there. On the y-axis, sine will be there with positive amplitude. Positive amplitude we will say. Positive sine also we can say. Okay. So always lagging 90 degrees. Sine is lagging 90 degrees with the cos. Equal. Or cos is leading 90 degrees with the sine. So this is the actual graph convention. Now I want to convert all the sine terms to the cos. So what happens? Check. This is achieved by using the following trigonometric identities. How? Sin A plus or minus B equal to sin A cos B plus or minus cos A sin B. First equation what I explained in the previous 2 slides. Now if it is cos A plus or minus B, then it is cos A cos B minus or plus sin A sin B. So these are the trigonometric conversions when we have sin AB term. Because what we are having, sin omega t plus phi phase, some phase degrees we are having. So we need A and B terms both. So that's why equation should be in mind. If sin is there, It should be sin A cos B plus or minus cos A sin B. If the cos is there, then cos A cos B minus or plus sin A sin B. It's just reverse and sign also will change. Now, using the following relationship, we can transform a sinusoidal form from sine to cosine from the vice versa. How? Sin omega t plus or minus 180 degrees can be given as minus sin omega t. Just use this formula. Then sin omega t plus or minus 180 degrees will be minus sin omega t. So what it is there exactly? This is sine. Okay. Plus 180 degrees. What means plus 180 degrees? It is going this side or this side. Both are same. Because plus 90 is plus 180 go clockwise or anti-clockwise. Both are same. But generally it should be clockwise. See, plus 180 degrees is going from here to 180 degrees. What happens in sine 180 degrees? So what happens in this minus will become. So this plus sign will become up, minus sign. Just substitute in this formula. Sine A plus or minus B. You substitute this formula. Omega t plus or minus 180 degrees. Then you will get minus sin omega t. If you take positive, means clockwise direction if you take, or negative clockwise direction, anti-clockwise direction also take, it is come opposite. Amplitude will change. Omega t will not change. Now here it is positive sin omega t. Then it will become upwards, minus sin omega t it will come. Same thing if we go for the cos. Cos omega t plus or minus 180 degrees, it is also having same relation, minus cos omega t. So from this cos omega t plus cos omega t, if we add 180 degrees, 90 if we add sin, another 90 if we add minus cos, it will come. Cos omega t. So the plus cos become minus cos if we add 180 degrees. Now sin omega t only we add 90 degrees. Only if we add the sin term only 90 degrees plus 90, it become plus cos. If we are adding plus 90 means what? Here. This is minus 90, right? Coming down. Clockwise is minus. Anti-clockwise is plus. Leading. Plus anti-clockwise. So, plus add plus 90 to upward. So, what become? Plus cos. Okay? Plus cos. Minus 90, it become minus cos. Here it will come. Now, cos omega t. Now, here cos is there. Reference now we have cos. It will be easy to understand now. What is cos omega t? Plus cos omega t is there. Now, I am adding minus 90. Cos omega t minus 90. See here. Second one. Cos omega t minus 90 degrees. What I am getting here? Plus sin omega t. See, this is the plus sin omega t. Okay. Now, if you add plus 90 degrees, means it has to go upwards. Plus 90 means go upwards, anti-clockwise. So, go upward, it become minus sin omega t. Same, in this equation, if you substitute, all will get the results. Don't worry. So, like this, the convention will be there. How the rotation will be there. Plus amplitude will change, minus amplitude will change. Now see the another result. Example is there. Okay. B. Sin omega t plus 180 degrees is nothing but how much? Sin omega t plus 180. This is sin omega t. Plus 180 means anti-clockwise. It will go upward. So it become minus sin omega t. It's coming minus sin omega. As per graphical, I can understand. Practical also, substitute in this equation, you will get same result. Okay. Now, the graphical technique can also be used to add two sinusoids of same frequency when one is in sine form and other in cosine form. No, I can add it, no problem. Previously I added two sine with phase difference, phi. Now I can add one sine, one cosine also. See here. So, this will be cos as per our previous graph and this is sine, right? Now, if you take, let us take amplitude. The amplitude should be there. Na? For cos and sine, there must be some amplitude, Vm. We have two different waveforms. So, one is A, one is B. So, this is the first is amplitude A for the cos. And the second one, sine amplitude B. So, what is the equation? A cos omega t. Then B sin omega t. These are the two equations we have. Okay. So, now, if you take these lines here and make the diagonal, what is the diagonal will be? C. And C is equal to under root of A square plus B square. Is perfect 90 degrees triangle. Right? This is the 90 degrees. This is also 90 degrees. Pythagoras, na? Yeah. So, as per that, so this is 90 degrees. So, exact triangle is there. This is the triangle, 90 degrees, perpendicular triangular 90 degrees is there. So A and this is B. So and what is the C? Hypotenuse C is equal to under root of A square plus B square. Square root of under root of A square plus B square is nothing but your C. Now what is the angle theta? The minus plus later. What is the angle theta as per A and B? We have A and we have B. This one is B and this is A. So what is the angle theta will be? Trigonometry. Theta is equal to tan inverse of B by A.
If we choose cosine,
Yeah, cosine if we choose, it will come different here. From here we have to choose cosine. But we need angle. This angle we need. We don't want sine and cosine. We want angle exactly how much delay, how much lagging, leading, we want that one. So that angle is given by the amplitude. We need amplitude because amplitude is given in the picture. So amplitude A and B is given. So angle will be theta is equal to tan inverse of B by A. So A cos omega t plus B sin omega t can be written as C cos omega t minus theta. If you add these two if you add, let us take A cos omega t and plus B sin omega t also can be written as C cos omega t minus phi. How much it's lagging? The resultant I am telling. The resultant. This resultant is nothing but your addition of cos and addition of sine. So A cos omega t plus B sin omega t. And also we can write with this diagonal. With this diagonal C, I can write with a cos omega t minus theta. So how much? From where C is nothing but under root A square plus B square. Now what is the theta? How much it is lagging? It is tan inverse B by A. So like this, how much it is coming back? Minus. That's why it's minus theta is there because it is clockwise. If it is anti-clockwise, it is plus theta. Now for example, let us take. We have 3 cos omega t and minus 4 sin omega t. Now draw the diagram. 3 cos omega t. 3 cos omega t, how it will be? Where it will be? Cos means horizontal, right? Plus means right side. Minus means left side. So what it is? Plus 3 cos omega t. So where it will be? This is, you can say 3. This is cos omega t. Good? This is the reference point 0. Now second one, minus 4 sin omega t. Sin omega t will be on vertical, maybe down or up. Down is plus sin omega t. Up is minus sin omega t. What it is there? Minus 4 sin omega t is there. So minus will be upward. So here, this is sin omega t. And this is your minus 4. Done? Now, make the triangle. Now I need the addition of these two. First we need C, which is equal to under root of
A plus
3 square plus minus 4 whole square, anything. These are this up to you. So it is becoming how much? 5. You can check. 3 square is 9. 4 square is 16. 9 plus 16, 25. 25 square root 5. Done. Now what is the angle? Angle. Now cos omega t is A and B is minus 4. So tan inverse of theta is equal to tan inverse of B. What is B? B is minus 4 by A is 3. So find the angle. 53 point something will be 53 degrees something will come. Check. Tan inverse of minus 4 by 3. 53 minus coming or plus coming, you have to tell.
minus 0.927.
No, change into the degrees.
A degree? Yep.
Change your radians to degrees. Did you use tan inverse or tan?
Tan inverse.
Okay, good. Something will come 53 degrees, but I am not sure. Plus minus, I am not sure. That's why I asked. So this is you can check here now. Oh, we have to close it, right? So you have to close it.
Minus 53.
Yeah, minus 53, right?
0.130.
Minus 53, good point. Minus 53. Minus means what? Anti-clockwise or clockwise?
Clockwise. This one.
Clockwise is
Yes.
down.
Minus, yes, clockwise.
Yeah. From where? This one, right? So minus 53. This is your 53 degrees. Now minus theta. We'll check the triangle. So just close this. Then see. This is plus 3. This is minus 4. 53. Plus 53, I think, not minus. From the cos. Minus 4. What is minus 4? B by A. B by A tan inverse. Yeah. Trigonometry angle, it rotate in the clockwise.
Okay.
Then it is minus means where it is to go? Upward. It is going from cos to sine. Because we're taking minus sign here, minus 4. It is going from cos to, because the angle should be in between these two only. The angle should be in between these two only. Not from the downside. So it should be opposite to the actual angle. So it should be upward. Okay. So this is how we got this one 5 cos omega t plus 53 point. And here what we write? Plus. Means leading. What you write downwards? Minus. Lagging. Right? Here we are writing leading. So plus anti-clockwise. Okay. Okay. Find the amplitude phase. Oh, sorry. Okay, we have another. We'll do it in next class. Okay, let's come to the chapter 6, the second part, that is sinusoids. I didn't finish the examples. One more example, two more examples. I have to finish the problem. So sinusoids. What we studied in the sinusoids? These are sine and cosine terms will be there. So some example let's have. Okay, the graph. Okay, I think we already finished this. Yeah, find the amplitude, phase, period, and frequency of the sinusoid. So V of t is equal to if 12 cos 50t plus 10 degrees. So this 10 degrees is nothing but the angle which it is lagging or leading, we can say. Plus 10 degrees means it is leading. So minus means it is lagging. So what we need? Amplitude we need, phase we need, period and frequency. So what is amplitude? It is directly Vm is equal to 12. 12 volts is the amplitude. How it is varying from 0 to 12 and from 12 to 0 and 0 to minus 12 and minus 12 to 0. So that is amplitude. It's nothing but 12 volts. Now coming to the phase. Phase angle is nothing but how much it is lagging or leading. If nothing is lagging or leading, it is 0. So phase is nothing but 5, 10 degrees. Whatever it is coming plus or minus some angle is coming, that is called phase. How much is leading or how much is lagging. It is plus 10 degrees means it is leading, we can say. Okay, the angular frequency is nothing but omega, that is 50. This is cos omega t. So 50 t, that is. So omega is nothing but 50 radians per second. From question itself directly we can understand. So the formula is like the equation is like this. V of t is equal to Vm cos omega t plus phi. So Vm already we got, phi we got 10 degrees, and omega we got 50 radians. Now we need the period and the frequency. If we know the angular frequency, then what is the period? T is equal to 2 pi by omega. It is 2 pi divided by omega. So substitute, it is T is equal to 2 pi by omega. 2 pi in radians you have to substitute, then divided by 50. Pi also in radians, don't put in 180 degrees. It will be problematic because down omega is in radians. Then how you put the pi in 180 degrees? No, it should be in radians. What is pi value? 3.142. Right? So multiply this 2 into 3.142 divided by 50. You will get 0.1257 Tania seconds. So this is period. The period, one period how much? 1 t means for one cycle how many seconds it is taking? It is 0.1257 seconds for one cycle. For positive and one negative, Jama. So now what we need? Frequency. Means how frequently it is moving. Means how frequently it is going on. Means what we have to do? We need, for one cycle it is 0.1257 seconds. Then in 1 second, how many cycles we want? That is called frequency. Means how frequent in 1 second. How frequent it is moving. So it is nothing but 1 by t is nothing but your frequency. 1 divided by t. So frequency is nothing but 1 divided by t. So 1 divided by 0.125 seconds is nothing but 7.958. For example, 8 means in Wahid Taniya, in 1 second, Tamaniya Marra Hada cycle is there. 1 cycle means Tamaniya Marra positive cycle, Tamaniya Marra negative cycle. It's there in Wahid Taniya, 1 cycle. So our Seco company, methane 20 volts supply, AC supply is there. What is the frequency? 60 Hz means Wahid Taniya 60 marra hada positive and negative will come. Wahid 60 marra positive, 60 marra negative means 16 cycles in Wahid Taniya. So this is one example. Another example is that. Then we go to the phasor. So calculate the phase angle between V1, that is minus 10 cos omega t plus 50 degrees, and V2 12 sin omega t minus 10 degrees. State which sinusoid is leading. Which one is leading? Now here the problem is, one is cos format, one is sine format. For this what we have to do? Both should be in same format. We have to convert. Then we can say which is leading and which is lagging by directly seeing the plus 5 and here minus 5 by directly seeing. First you have to convert that one. Either or. Either you convert this into sine or convert this sine to cos. Up to you. So we have some method. 3 methods I have. First method, in order to compare V1 and V2, we must express them in same form. If we express them in cosine form with positive amplitudes, then amplitudes also we have to change. Now, V1 is minus 10 cos omega t plus 50. How can we write? With positive amplitude minus 10, I will write 10. Then this minus will go inside with minus 180 degrees. Means if you change the amplitude to minus to plus, that is minus is there. Now I want to plus. So 180 degrees it will push. It will lag. It will drag. You can say it will drag 180 degrees baad. So that is called minus to plus. How we can convert? Just we have to drag it or negate it with minus 180 degrees. You have to push it to 180 degrees. Then it will come to positive. This minus will become positive. So now it becoming 10 cos omega t plus 50 as per equation minus 180. Now rearrange this minus 180 and 50. It is minus 130. So then it will become 10 cos omega t minus 130. Now again we can write cos omega t. Also we can write this minus 130. We can write plus 230. How? Just add with the plus 360. If you add with the plus 360, it become 230. Right? No, not plus 330. Minus 90. Minus 90 means you have to negate again. So it become plus. So 230 it is. Now we can check another one. V2 is 12 sin omega t minus 10 degrees. V2 is sin omega t minus 10 degrees. So 12 cos omega t. How can we convert this into cos? Sine to cos. Just we have to 90 degrees push. That would sine and cos are in the format where with each are 90 degrees each other. 90 degrees difference. Sine will start from 0 to maximum and coming to the 0 and negative maximum 0. Cos will start maximum to 0, 0 to maximum and 0 negative maximum and 0 and maximum. So it will start from the maximum value. Means it will not start from the 0 degrees. So how can we write sine in cos? With minus 90 degrees. So cos omega t minus 10 minus 90. So just Jama it is minus 100. So V2 is equal to 12 cos omega t minus 100. And V1 is 10 cos omega t minus 130. So this is minus 130 and this minus 100. Which is the biggest one? This one. So this is minus 100. Baad 30 degrees hada iji. Right? 30 degrees is baad. So V2 is leading V1. Means V2 awwal baden V1. Because hada V1 is baad 30 degrees. Compare this. Omega t minus 100. Omega t minus 100 minus 30. So minus 30 baad iji hada. So V2 is leading V1 we can say. Okay. It can, so it can be deduced from equation phase difference V1 and V2 is 30 degrees. We can write V2 as V2, we can write 12 cos omega t minus 130 plus 30. So V2 will be 12 cos omega t plus 260. Also we can write this one. Then comparing these two equations, V2 leads by V1 30 degrees. So by directly you can see from here also we can say this and this, it is minus 30 degrees. So 30 degrees leading, V2 is leading V1 by 30 degrees. Now another method 2. Alternatively, we may express V1 in sine form. I am converting this into sine form. So what we have to do? Plus 90 degrees. Okay, not minus 90 degrees, plus 90 degrees. So V1 is minus cos omega t plus 50. So first convert this into positive value amplitude, positive amplitude, that is minus is removing from this 10. So it will be minus 90, same what we did here. So find sine and make it to sine. So minus 90 will come. So 10 sine omega t minus 40 we can write, that is the deduction. Then 10 sine omega t minus 10 minus 30, because V2 is, what is V2? It is minus 10 already there. So first put omega t minus 10, remaining you keep it here from this one. So omega t minus 10, remaining is minus 30. So here also minus 30, which one? It is V1. So V1 is lagging V2. So V2 is leading V1, we can say. So V2 is lead by 30 degrees, same thing. So next another method we have, or in the graphical way I can see. Here cos omega t generally on x-axis, already I told you in last class, and sin omega t is on the y-axis. So what is the equation we have? V1, let us take. V1 is minus 10. Minus will be which side? Back side. V1 minus 10. Plus 10 will be on the right side. Minus 10 on the left side. Right? So minus 10. Cos omega t plus 50. So plus 50 means after this plus 50 it is anti-clockwise always be there. I told you anti-clockwise will be there. So 50 degrees here. This is V1. This because it is minus 10 on the left side and 50 degrees is the plus 50 and it is V1. This is the arrow. Now next V2 is nothing but 12 sin omega t minus 10. 12 is positive side where it is sine. This is a positive and this is the upside is negative. This is a positive side, sin omega t. So plus 12. So positive side. Now how much angle? Minus angle. If it is plus angle, it should be on the right side. But it is minus 10, it is on the left side. So we can write as V1 and V2. Now see here, this is 50 degrees and this is 10 degrees. What is the total angle here? 90 degrees. So 90 minus 60. How much? Total angle is 90. From here, this point to this point, total angle is 90. Now, here already 50 and 10 is finished. So, 50 and 10, 60. So, 90 minus 60, it is 30 degrees. So, the remaining, the angle between V1 and V2 is 30 degrees. But we can see which one is coming first. V2, because it is, when you are rotating, it is anti-clockwise. Which one is coming first? V2 is coming first, then V1. So, V2 is leading V1. Anti-clockwise, na angle. See here, angle is 50 degrees and 10 degrees. Minus means this side. Plus means anti-clockwise. Minus means clockwise. Plus anti-clockwise. So V2 and V1 30 degrees we know. But which is first, which is last, we can say anti-clockwise. Anti-clockwise rotation. V2 is coming first and 30 degrees baad means after 30 degrees V1 is coming. So V2 is lagging. Sorry, V2 is leading V1. Lead V1. This is important. Check here. So, by graphical way also we can tell this is the answer. No need of conversion and everything here. This is, I think, very easy for you. Anti-clockwise you have to remember. That's it. Okay? Okay, now coming to the phasors. Another topic we have phasors. Another 3 topics we have. So, sinusoids are easily expressed in terms of phasors. What are sinusoids? Sine, cosine terms can be converted into or can be represented in the phasors for our easy calculation in day to day. So no need to go for sine 30 how much, sine 180 how much, sine 90 how much. No, just convert it to phasors which is having a complex numbers. So complex calculation in the calculator is also easy. So that we have to see. So phasor is nothing but a complex value we can say. We have 3 types of values. What are these? 3 types of representation. One is absolute. Phasors are 3 types of representation. Absolute value, another one is rectangular and polar. These three will be there: absolute, rectangular, and polar. So that we will study inshallah. So which are more convenient to work with than sine and cosine function? So I'm not good in sine and cosine. I want in complex terms I am good. Then we go for the phasors. Okay, phasor is a complex number that represents the amplitude and the phase of a sinusoid. Okay, is a complex number, represent a phasor is a complex number, a plus jb. Generally a plus jb, what is it? It is a complex number, something with having a j format. It is a complex number which represent its amplitude and a phase of a sinusoid. Here what it's telling, amplitude and phase of a sinusoid, it is Vm cos omega t plus phi. What is phi? It is a phase. How much angle it is, delay or lead or lag. This one amplitude Vm. So it phasor will tell a complex number that represent the amplitude and phase of a sinusoid. Okay, amplitude is Vm. Phase is nothing but plus, that is plus or minus phi. That is phase. So which will represent in the phasor in the form of complex number. A complex number z, we generally denote the complex number generally with z. Okay, can be written in the rectangular form. So we have told you three formats are there. We have rectangular form and polar form, absolute form, right? So rectangular form, z can be written in terms of z is equal to x plus jy. This is the format of a complex number, x plus jy. Generally the term is z. The rectangular form of complex number, where x is the real part and y is the imaginary part of the j. So how to find x and y, we will see. So in this context, the variables x and y do not represent a location in two-dimensional vector analysis. So when you study vector analysis, this imaginary and real part x and y do not represent any location in the two-dimensional vector analysis. They have another phasor diagram will be there. There it will represent, that we'll study. But rather real and imaginary part of z in complex plane. We have two planes are there, that is called two-dimensional plane and complex plane, both are different. So don't mix up with these two. So z always with the complex plane, we have x and y values. One is imaginary, one is real part. That I will show in the next slide. Okay, the complex number z can also be written in polar or exponential form. So I told you we have three format. One absolute, remove it, because when complex number is coming, either follow polar or rectangular. Rectangular with x plus j y and rectangular. Polar is with an angle. With an angle it will come. Some value with an angle. So that we will see. So z is equal to r at an angle of phi. You all can r at phi. We can say r at an angle of phi also we can say. Where phi is the phasor angle and r is the value of x square plus y square whole under root. What is r? From where it is coming? R is coming from under root of x square plus y square from the rectangular part. And phi is nothing but your tan inverse of y by x. So that will come inshallah. So we can write in this form as a polar r at an angle phi, or we can write exponential form. This is called exponential form, r e power j phi. Both are same. So both are in polar format only. In polar format we have angular format and a exponential form. In both angle is there. Phi is the angle. This phi is the angle. So this is exponential form of polar and normal polar format. So where r is the magnitude of z can be found under root of x square plus y square. And phi is the phase of the z, and that is tan inverse of y by x. So we notice that z can be represented in three ways. So first one, basic one, x plus jy. The second one, r at an angle of phi. The third one, r at exponential of j phi. So these are the three format. So z x plus jy is called as rectangular form. Z equal to r of at an angle phi is called polar form, and z equal to r e power j phi is called exponential form. So these three formats are there for phasors. Any phasor we can represent in these three formats. Okay. Okay. Now see here how the complex number can be represented. It's in plane. So it is real axis on the right hand side, and that is x axis we call, and imaginary axis on the y axis. So this is your real axis x generally, and imaginary axis we have y. So if we have x and y, what is the diagonal? It is nothing but resultant. Diagonal r resultant is nothing but x square plus y square completely under root of x square plus y square. Now the angle between x and r is nothing but phi. Our angle between y and r is also nothing but phi. This phi and here this phi both are same because it is a right angle triangle. It is a right angle triangle. This phi and other side phi both are same. So now what you assume here? Okay. So okay, next. Okay, the relationship between rectangular form and polar form is as shown in figure, where x is represent the real part and y represent the imaginary part of the complex number x plus jy. Okay, now given x and y, we can write r and phi. X and y already given. So what is r and phi? We can directly write. What is r? X is under root of x square plus y square. What is phi? Tan inverse of y by x. X square plus y square under root, that's nothing but r. Phi is nothing but tan inverse of y by x. Now, on the other hand, if we know r and phi, we can obtain x and y as. So let's say only it is given r and phi is only given. The resultant in polar form, r given and phi only given. We have to know what is x and y. So by this plane, complex number plane, how can we know? If r and phi is given, then r sine theta. What is r sine theta? Y. What is r this side? Cos theta is x. So there is nothing but x is equal to r cos phi, y is equal to r sine phi, because theta I am using here phi. So this is general trigonometric equation as per this diagram. So you can remember this one, x is equal to r cos phi, y is equal to r sin phi. Draw this one, you can directly get that one. So another thing, so that's why we can write z is equal to x plus jy in the rectangular form, r at an angle phi, it is in the polar form, and also we can rearrange in terms of cosine and sine terms also. See, phasor now converting to sinusoid also. So we can write r cos phi plus j sine phi. Now conversion I am getting. So what I told you, it is just I explained what is the what we call phasor and what is the sinusoid we explained. Now interrelation I am telling here. What is interrelation? Which is nothing but z is equal to x plus jy, which also can be written in polar form, which in terms of sinusoid is nothing but r cos phi plus j sine phi. Okay. Now this again we can elaborate. How? Basic properties of complex number. Okay. Before going to that relation of phasor and the complex number, we just will study how the phasor can be behave in terms of addition, multiplication, division, conjugate. We'll study that one. Then we'll go to the interrelationship. So addition and subtraction of a complex numbers are better performed in rectangular form. We have three formats, right? What are three formats? Rectangular form, polar form, and exponential form. Okay, three formats we have. In that, addition and subtraction, anything if is given in the complex number in these three format, better if he is asked for addition and subtraction, then convert it into rectangular form, x plus jy. In this form, we convert it, easy to add and easy to subtract. Remaining, you can use polar form. For division and for multiplication, use polar form. It is easy. Multiplication and division can be better done by in polar form. So given the complex numbers, what we have, z is equal to x plus jy, r at an angle phi. Then let us take two different complex number I am giving. Z1, x1 plus j, y1, r1, phi1. This is the first complex number. Now let us take second complex number, z2, x2 plus j, y2. This is nothing but r2, phi2. Now I want to perform addition, subtraction, division, and complex conjugate. Let's take. So what I told, addition and subtraction, I used rectangular form. So I use in this form, x1, j1, jy1, x2 plus jy2 format. Addition is direct, x1 plus x2 with y1 plus y2, or x1 minus x2, y1 minus y2. It is direct. Don't go with addition and subtraction within the polar form. R1 plus R2, it will not work. R1 plus R2, phi1 minus phi2, it will not work. Okay, go convert it into rectangular form, then add directly x1 plus x2, y1 plus y2, or x1 minus x2, y1 minus y2. The following operations are important. Addition. Z1 plus Z2 is this. X1 plus X2 plus J Y1 plus Y2. Same subtraction. X1 minus X2 J times Y1 minus Y2. Direct. Now coming to the multiplication. Z1 multiplied by Z2 is easy in the polar form. In the polar form, it is easy to multiply the complex number. Z1 is nothing but R1, 5 at phi 1 and R2 at phi 2. So directly multiply R1, R2 and angle is always added. It's phi 1 plus phi 2. Don't multiply two angles there. Here two rules are there. When real part is there, the resultant part is there R1, R2, it must be multiplied. The angular part must be added. Okay, if it is negative sign is there, that will be negated. Whatever happens, that's later. But it must be added. Phi 1 plus phi 2. Sometimes phi will be minus, sometimes phi 2 may be minus. As per resultant, it will come. But you have to add when it is multiplication. Z1, Z2, when it is multiplying, the angular format should be added. When it is in division, the angular format should be negative. These two keep in mind. What is division? Z1 by Z2 is nothing but same R1 by R2. The phi 1, phi 2 in addition, it was phi 1 plus phi 2. But here, phi 1 minus phi 2. Here, just you have to subtract. So, this you have to remember. Some examples will also be there. Now, coming to reciprocal. When your reciprocal means inverse. 1 by Z is nothing but 1 by R. But the angle, what it is there, it will go up. It will become minus. Negative. That's why it is here. When it is dividing, the angle it is going up and it is phi 1 minus phi 2 is coming. That's why. Okay. Here also 1 by Z2 is nothing but 1 by R2. So angle is going up minus. So when it is multiplied, it is phi 1 minus phi 2. So reciprocal. Now coming to the square root. What is under root of Z? It is, we can have under root of R, but phi has to be Taksim by 2. It is not under root. It's like exponential. Exponential of square root. What is exponential of square root? It is half. This e power 1 by 2 it is. So it becomes phi by 2. So z under root of r and at the angle phi by 2. That is square root. These are the another rule. Complex conjugate. What is a conjugate means? The imaginary part become negative. Changing the imaginary part from positive to negative or negative to positive. If you already have positive, make it the imaginary part to J part. J is called imaginary part. If already positive is there, make it to negative. If negative is there, make it positive. Conjugate. That's why Z. That's why we call Z star. That in the top you will write star. That is called conjugate. So x minus jy. Generally x plus jy is there. Now we will write x minus jy. Now in the angular polar form r minus phi. In the exponential form r e power minus j phi. These three formats also there. Okay. What is 1 by j is nothing but it is minus j generally, which will change the angle. Okay, now coming to the relation. The idea of phasor representation is based on Euler's identity. The one scientific name is there, Euler. He find the rules for that. So what is that? It is e power plus or minus j phi. It is there in exponential form. E power plus or minus j phi something is there. Let us take. Then that e power plus or minus j phi can be written in terms of cos phi plus or minus j sin phi. This already we studied in the but one previous slide with the polar form, the diagram. In the diagram, if r is known and how to find x and y. If r is known, how to find x and y? X is nothing but r cos phi. Y is nothing but r sin phi. Same thing here. Cos phi plus or minus j sin phi, which will give this imaginary part. This imaginary part e power plus or minus j phi is nothing but your imaginary part. It is cos phi plus or minus j sin phi. Now multiply with the amplitude r, then it complete the complex term. R times cos phi plus or minus j sin phi. It is a complex term. Okay, which shows that we may regard cos phi and sin phi as the real and imaginary part. So cos phi will come as a real part and sin phi will come as a imaginary part of this e power j phi. So we are separating e power j phi in cos phi and sin phi, where cos phi will represent the real part and Sine phi will represent the imaginary part of your complex number. So then we can write cos phi as real part of e power j phi, this real part of this e power j phi, and sine phi as imaginary part of e power j phi. So where RE and IM stands for real and imaginary. Given in sinusoid, we know now coming to the original equation. How our equation in voltage current is there, this one. Now we have to convert that into phasor. So VA sinusoid, given sinusoid V of t is nothing but Vm cos omega t plus phi. We know this equation from the first 3 slides, which is the voltage instantaneous voltage format of AC, alternating current voltage format. V of t is nothing but Vm cos omega t plus phi. Now express V of t. V of t can be expressed in the form of Vm cos omega t plus phi. Now I can rearrange this one like a real part of Vm e power of j omega t plus phi. What is real part of Vm e power of j omega t plus phi? Why I am writing? Just check. Where V of t is nothing but real part of from here cos omega t plus phi. How can I write cos omega t plus phi? This one cos omega t plus phi. I can write real part of e power of j phi. So I can write cos omega t plus phi as e power of j omega t plus phi. I can write. Okay, this cos omega t. This is a real part, right? Where is the cos here? Real part. So that's why I have to use this one, real part. So real part of Vm as it is, it will go inside, no problem. But cos omega t plus phi I can write in e power this format, plus or minus j phi. So e power of j omega t plus phi, which is as per the equation. So now I can separate it. I can separate it. E power j omega t plus phi I can write e power of j phi multiplied by e power of j omega t. Right? Exponential summation can be written as exponential multiplication. You can write exponential summation, that is e power of j omega t plus j phi. I can separate it by multiplication. If you multiply, same will come. E power of x and e power of y. What is the value? E power of x multiplied by e power of y. What is the value? E power of x plus y. Right? The power will be added when it is multiplied. So like this, e power of j phi, e power of j omega t I separated here. Now Vm j omega t I will rearrange. So generally what is it is in this form of a phasor may be regarded as a mathematical equivalent of sinusoid with a time dependent the time dependence drop. Now the phasor can be mathematically equivalent, we can write real part. Time dependence we can remove it. How? So thus we can write V of t is equal to real part of V e power of j omega t. Now I rearrange V e power j phi together, which is a phasor angle. Which is a phasor angle. I am just multiplying these two, Vm e power j phi. I am writing as a capital V. So capital V is nothing but your, which is a constant one. So Vm e power j phi. Now remaining e power j omega t I will keep, which is a time dependent. V is not a time dependent because it is a phase angle only. It's not depending on time. T I separated and phi is phase angle I separated. Previously it was time is together and phase angle also together in the cosine term. Separation is not there. So now in phasor form I can separate it and I can analyze it. So I separated the non-time dependent, that is phasor angle, and I separate the time dependent e power of j omega t is separated. So I can multiply. So wherever equations are coming, I can directly apply. Okay, where V is nothing but Vm e power j phi. Also we can write as Vm at an angle of phi. So how is this format? Vm at an angle of phi. R e power j phi. What is R e power j phi? R at an angle of phi in polar form. This is in exponential form. It is in polar form, Vm at an angle phi. So what it is there? If we use sine for the phasor instead of cosine. Now here cos is there. Now if we use sine, Vm is sine omega t plus phi. Then how can we write? Imaginary part we have to use because this one we have to use. Right? This is cosine. Cos. Cos is there. Cosine is there. So we use which part? Real part. Now if we have equation, the voltage or current equation in sine format, then we have to use the imaginary part. So that's why I have to write imaginary of Vm e power of j omega t plus phi. Same. And the corresponding equation will be same. Whatever happens, Vm will be, Vm of phi will be there same. But here it will become imaginary. It become imaginary part. That's it. Remaining all will be same. Okay. Now, equations 9.21 through 9.23 reveals that to get phasor corresponding sinusoid, so equal relation, how can we get a phasor to sinusoid or sinusoid to phasor? 9.21 and 9.23 we can get. This is the 9.21 where V of t in terms of sinusoid. Now, this is in terms of phasor. That is real part of Vm e power j omega t plus phi. This is in terms of phasor. Now, one equation. Another equation, if you rearrange this equation, that is real part of V e power of j omega t. So, these two will tell the relation between phasor to sinusoid. So, we converted the sinusoid to the phasor. So, which is nothing but V of t, which is equal to Vm cos omega t plus phi, is nothing but real part of V e power of j omega t, where V is nothing but Vm e power of phi. Okay, what are the important points in this? We first express the sinusoid in the cosine form. General easy term is real part. Playing with real part easy, not imaginary part. Imaginary part, that is all imaginary it is. So we have to try to omit that one, means delete that one from our equations. It is easy for any further calculation. So take cosine part of the sinusoid. If equation is given sine also, you know how to convert it into cosine. Just minus 90 degrees, right? Add minus 90 degrees and it will become cosine. Now with this cosine, we can convert it as real part of V e power of j omega t. We can convert it. So we can go further. So we first express the sinusoid in the cosine form so that the sinusoid can be written as a real part of the complex number. Okay, real part of the complex number can come only when it is in the cosine format of the sinusoid. Then what happens then? Then we take out the time factor. How to take out the time factor? Separate the phi, angle phi, term and amplitude. Separate it, then time factor will be separated. Okay, that is a constant factor. Okay, and whatever left is the phasor corresponding in the sinusoid. Time factor is e power of j omega t. This is a time factor, we separated. Remaining all is nothing but V, which is a phasor quantity. That is Vm e power of phi, j phi. By suppressing the time factor, we transform sinusoid from time domain to the phasor domain. So, the part we are separated from the time domain to phasor domain because we are removed, or in multiplication we keep time domain separate. Therefore, this transformation can be done as V of t is generally we will write in the sinusoid Vm cos omega t plus phi in time domain representation because omega t is the time domain time. Now we separate it in terms of V is equal to Vm of phi, which is a phasor domain. Okay. Now how we can convert this time domain to phasor domain? See here, Vm cos omega t plus phi is there. Then what is the phasor form of this Vm cos? This is MCQ question will come. Vm cos omega t plus phi converted into phasor form. It become Vm at an angle phi directly. Now Vm sin omega t plus phi. Always go with the cosine term, right? So first convert this sine into cosine term. What happens? Vm cos omega t plus phi minus 90 degrees. Okay, Vm first we have to convert the sine to cosine. Vm cos omega t plus phi minus 90 degrees. So the phi minus 90 degree become your phasor. Okay, Vm is as it is, that is the amplitude. Vm is amplitude at an angle phi minus 90. Previously it was phi, now it is phi minus 90 because I am converting this sinusoid to the cosine term. Now Im cos omega t plus theta, if it has some angle, there is a phi we call here, some other name theta. So it is same, Im at an angle of theta. Now Im sin omega t plus theta, it become Im theta minus 90 degrees. So like this we have phasors.
Victor, please can you take attendance now because I have a meeting.
At what time? 11? Which?
11 and
Okay. How many are there? Okay, you have my number now? Just WhatsApp and go. Anyone, you take care. Send WhatsApp name and ID number. Send the WhatsApp, 2-3 people and go. Okay. Okay, next, the phasor domain is also known as frequency domain. Why? Because the phi we separated. Phi we separated. This is a phase always. Now we converted the time domain into frequency. 1 by 2 pi by omega is nothing but your frequency t. Now 1 by t is nothing but your frequency. So it is called frequency domain. Differentiating sinusoid is equivalent to multiplying its corresponding phasor by JW. So when you differentiate the sinusoid, sin omega t, cos omega t, it become real to imaginary. Imaginary become real. So differentiate when you sine, it become cosine, right? So in the phasor, the sine when you is converting into differentiating, it become imaginary, j omega t. Otherwise, a real part. So thus the derivative of v of t is transformed phasor domain as j omega v. So it is converting to j omega v. Now dv by dt is converting as j omega v in phasor domain. If you integrate, it's reverse. 1 by j omega will come. Now similarly, integrating sinusoid is equivalent to dividing its corresponding phasor by j omega. Both are converting from real to imaginary. But in differentiating, it will be multiplied by j omega. In integrating, 1 by j omega will come. 1 by j omega will come. 1 by j omega will come. Here, multiplied by j omega will come. Both are converting to imaginary. The difference between v of t and v as follows. What is v of t? It is instantaneous. And what is v? It is a constant. First one, v of t is an instantaneous or time domain. V of t is an instantaneous or time domain because it has cos omega t. Omega t means time domain. While v is the frequency or phasor domain. V is having only phase angle, no time domain. So it is a frequency or phasor domain. Capital V, the difference between these two. Now v of t is the time dependent because of the omega t, and while v is not, it's not depending on the time. It is only generally it's a constant term. Once you know the phase angle, how much delay, how much lead, how much lag, then it's a constant. Now v of t is always real with no complex term. V of t is always real with no complex term because it's a cos omega t plus y. There is no complex term in that. Cosine, sine, no complex term. But in phasor, v is generally a complex term because it is a v at an angle of phi. V is nothing but what is Vm at an angle of phi. It is a complex number. Polar form. It is a polar form of the complex form. Now, finally, we should bear in mind that phasor analysis applies only when frequency is constant. That's why when voltage is given, current is given, and the delay, the lead or and lag phi is constant. It's not changing. Okay, omega t time domain is changing. I know it's varying 0 to maximum 0 in the some time domain, but delay, one waveform is starting at an angle of 0 and other waveform starting at an angle of plus 30. So it is constant. Always it's maintaining. It's maintaining first wave and second wave is maintaining. No. So it is a constant we can say. So what we say? Phasor apply only when frequency is constant. F is constant. It applies in manipulating two or more sinusoidal signals only if they are in the same frequency. So both are in the same frequency, then only we can apply. Okay, we have example. First example, evaluate these complex numbers. So one complex number is 40 at an angle 50 degrees plus 20 at an angle minus 30 degrees. We have to square root. I think I missed that calculation square root. No problem. We will do it. So 40 at an angle 50 degrees plus 20 at an angle minus 30 is the first question. What we have to do? We have to first sum it, then square root, under root. Right? So it is in polar form. 48, 50 at an angle 50 degrees, 28 at an angle minus 30 degrees in polar form. Can I add directly? Addition and subtraction is in polar form is possible. Is a good technique? No. We have to do with a rectangular form. How the rectangular form? X plus jy. Right? So first convert these 40 to 50 degrees and 20 to minus 30 rectangular form. Then directly add it. It is easy. Then make square root. That's different. Okay. Then again convert it to polar. Then square root. Now see 40 at an angle 50 degrees. If we convert to the rectangular form, what it will be? It is r cos phi plus j sin phi. That is r is 40 cos 50 degrees plus j sin 50 degrees. So cos 50 degrees multiplied by 40, you will get 25.71. You can check. Sin 50 degrees multiplied by 40, you will get 30.64. First term. Second term 20 at an angle minus 30. So convert this to 20 cos minus 30 plus j sin minus 30. So cos minus 30 multiplied by 20, you will get 17.32, and sin of minus 30 multiplied by 20 degrees, you will get minus 10. Okay, so now we got in the rectangular form, x plus jy form. Now just directly add it. 25.71 add to 17.32. 30.64 add to minus 10. So it will give the result. What is the result? 43. See here, 25.71 plus 17.31, it is 43.03. 30.64 minus 10, it is 20.64 plus. That is. So now once you know this format, x plus jy, convert it into polar form. How we convert into polar form? Under root of x square plus y square is the r. What under root of square root of 43.03 square plus 20.64 square. You will get the r. That is 47.72. What is the angle? Angle is nothing but tan inverse of y 20.64 divided by 43.03 y by x. Okay, tan inverse. Then you will get this angle. Once you know this one, square root. How the square root is coming? I told you. Square root is nothing but 47.72. Just make a square root. What is the angle? 25.63 square root. It has to be make half. Make nus. Okay, make it nus of 25.63 by 2. That is your square root. So that I missed, I think, here. Okay, now come to the B part. Now it is in polar. Oh, this is a big complex number. What is that? One is the polar format and other is the plus rectangular format. Taqsim zarb of one is rectangular format, another also rectangular format with a conjugate. Star means conjugate. So, okay. Just check here. 10 at an angle minus 30 plus 3 minus j4. I have to convert this into rectangular form. 10 at minus 30 convert into rectangular form. It will become 8.66 minus j. So plus 3 j4 will be as it is. So just sum it this one. Now down. This is conjugate. When you are using conjugate, what is there? 3 minus j5. Or it will become 3 plus j5. So now multiplication. Rectangular form is good? No. Multiplication should be in the polar form. So convert these two downside, these two rectangular form to polar form. So it become top one is become 11.66 minus j9. Now down one multiplication will come convert into polar form and multiply it. Then you will get minus 14 plus j22. So it is 26.08 and angle. Now divide. When you divide this one, this will be division as it is. Now this one will be minus 37.66 minus 122 because it's coming up minus 22 because when division is there minus. So it is 160.13 with a minus angle. So like this we have to finish this one. Now another example we will study in the next class, inshallah. Okay, let's start. So in previous example, we have finished one example. This is the second example. Transform these sinusoids to phasors. I is equal to 6 cos 50t minus 40 degrees and V is equal to minus 4 sin 30t plus 50 degrees. So we have to transform this into phasors. What we are to doing? I is equal to 6 cos 50t minus 40 degrees. Phi is nothing but minus 40 degrees. Omega is 50 and Im is 6. So generally phasor is equal to capital I is equal to Im at an angle phi. So Im is nothing but 6. What is the phi? Minus 40. So it is Im, that is 6 at an angle minus 40 is your phasor. So first one. Now come to the second one. V is equal to minus 4 sin 30t plus 50 degrees. So generally I told you we have to convert this sinusoid to cos. Then we have to convert into the phasor. Directly sine we cannot convert to the phasor. So first convert it into cos term because it is given in sine. So when minus sine is there, how the angle will change here? It is minus sine will become here minus or plus 90 degrees. If only sine is there, plus sine is there, no minus, plus sine is there, then the cos will nothing but cos of minus 90 degrees. But here minus sign is there, so it is plus 90 degrees inside. So it becomes 4 cos 30t plus 50 plus 90 degrees. See here, it is minus sign, it become plus cos, which where it will add after the 50, it will add plus 90 degrees. Generally it has to add minus 90, but it has minus outside, we are taking inside that minus, it become plus. So plus 90 degrees. So total will become 50 plus 90, it is 140 degrees. So it is actual equation of V will become 4 cos 30t plus 140 degrees. So it becomes 4 cos 30t plus 140 degrees. So now convert this into phasor. V is now in time domain. Now convert it into frequency domain. That is phasor. Is nothing but Vm is 4. Omega is 30. Angle is 140 plus 140. So what is V? Capital V is nothing but Vm at an angle phi. So Vm is 4. So 4 at an angle 140 degrees it becomes. V is equal to 4 at an angle 140 degrees. Direct answer. So whenever sine terms is there, we have to convert it into first cos. Then directly you can write the equation. Easy. If cos is there, you can write directly I equal to Im at angle. But it is in sine term. First we have to convert it into cos. Then we have to change to V is equal to Vm at an angle phi. So this is one example. Another example I think there. Yeah. Find the sinusoid of represented by phasor. Now phasor is given. We need a sinusoid in the sine and cos term. So I equal to minus 3 plus j4. V is equal to j8 e power minus j20. So first one we will find. So convert it into the what we call in the rectangular form into polar form first. So it will be easy to get the sinusoid. First convert this rectangular into polar. 3 and 4. X and y. What it will be? Under root of x square plus y square under root of. So 3 square is 9 plus 4 square is 16. 16 plus 9, 25. Under root of 25 is 5. So it becomes 5. That is minus 3 square whole square, minus 3 whole square plus 4 whole square root of this. It is minus 3 whole square is plus 9 only. So 25 under root is 5. Now angle. Angle is nothing but tan inverse of 4 y by x. 4 by x is minus 3. So tan inverse of 4 by minus 3 is minus 53 something will come. So convert it into plus. That is plus 180 degrees. So plus 180 degrees to minus 53, it become 126. It actually come minus 53. Tan inverse of 4 by minus 3 is become minus 53. But I need in the positive term. So just negate with the, join with the plus 180. So 180 minus 53 it become 126.87 degrees. Now this we can transform into time domain, that is sinusoid. How? This is your Im, this is your phi, right? So generally what it will be? I of t is equal to 5 cos omega t plus phi. This one. Omega is not given, so keep it as omega only. Omega if you want to calculate, that is different issue. So 5 cos omega t plus 126.87 degree as it is. So we need in polar form. If it is in phasor in polar form, then directly we can write in the sinusoid form. So next, now another thing, B. V is equal to j8 e power minus j20. Now we know that what is j? J is nothing but your minus, plus 90 degrees. J is nothing but 1 at an angle 90 means lagging. J when it is an imaginary part, it is 90 degrees always we have to add if you want to remove the j. Now I want to remove the j from this V equation. So just add here plus 90 degrees. So it become j8 e power minus j20 is nothing but it become j is becoming 1 at an angle 90 degrees and 8 at an angle minus 20 degrees. 8 at an angle minus 20 degrees. So multiply Zerb. Zerb multiplication is in polar form easy. X into y and phi 1 plus phi 2. So 8 at an angle 90 plus that is minus 20. So it becomes 70. So 8 at an angle 90 minus 20. It becomes 8 at an angle 70 degrees. Now you convert this 8 at an angle 70 degrees. It becomes 8 Vm cos omega t plus 70 degrees. So like this we can convert from phasor to sinusoid, that is time domain, or time domain sinusoid to phasor. Now coming to our actual electrical circuit problem, that is how these phasor and sinusoid related to the resistance, passive element, inductance and capacitance. We will study that one. Oh, another example, no problem. Okay. We have I1 4 cos omega t plus 30 and I2 sin omega t minus 20. So here sin term is there. Now we have to change into the cos term. So how we will change into the cos term? Phi cos omega t minus 20 plus 90 degrees, because it is lagging when sin term is becoming to the cos term. So now what is I1? It become from this equation I1 is 4 at an angle 30 degrees. Now I2, so we have to convert this to phi cos omega t minus 20 minus 90 degrees. So it become phi cos omega t minus 110. So write like I1 here in phasor form. I2 5 at an angle minus 110. I2 at an angle 5 at an angle minus 110. So now what he wants? Sum. Just we have to add these two. So how we will add these two? I equal to I1 plus I2. 4 at an angle 30 degrees plus 5 at an angle minus 110 degrees. Directly can we add? No. We need in a rectangular form. Addition, subtraction always with rectangular form, not in polar form. So change into the rectangular form. How the rectangular form will be? It is, if you change it to rectangular form, it is nothing but 4 cos 30 degrees plus j 4 sin 30 degrees. This will become 3.464 plus j2. Same here, 5 cos 110 degrees minus 110 degrees plus j sin 110 degrees 5 times. So it become minus 1.71 minus 4.69. So 8 will come. Convert this one. In your calculator you can convert directly also. It's easy. Or you can use your equation. It's up to you. So now join this x term here, 3.464 and 1.71. It become 1.754. Now j terms, j2 and minus j 4.698 is become minus j 2.698. So this is the result of this. Now convert this rectangular into polar form. X square plus y square under root. It becomes 3.218. Tan inverse of y by x minus 2.698 divided by 1.754. This will become tan inverse. So this is your angle. If you want, you can change into positive also. Minus 56.97 plus 180. That become your positive angle. Up to you. Okay, transforming. Now transform this in terms of time domain again. So it become, this is 3.218 as it is, that is IM. Now angle cos omega t minus 56.97. This is your angle. So this is how we add the phasor to the cosine, that is time domain, or time domain to the phasor. Next, another example. Oh, so many are there. Okay. This you can study, no problem. All steps are there because I have to. Here, generally, what we are doing, you want to integrate and differentiate as per given. So 4i is there, 8 integration I dt is there, minus 3 di by dt is there, then 50 cos 2t plus 75 is there. So what we have to do? 4i, okay. Integration of I is nothing but 1 by j omega. Differentiation is nothing but j omega. Then multiplication j omega. So that is 8i by j omega if we have integration. Now if we have differentiation is nothing but put di by dt, d by dt with j omega capital I. So and this you convert into the phasor, it become 50 at an angle 75 degrees. So now rearrange this one, 1 by j omega. Omega is equal to 2 as per this equation. What is omega? 2. So substitute here 2. So 1 by 8 by 2 it is minus, if it is 1 by j, it is nothing but plus 1 by j is nothing but minus, it become minus j. So minus j4 because 8 by 2. Now here 2 is there, 6. So 3 into 2, 6 here, minus 6j. So I taken out, so minus 4j and minus 6j become 10j. So 4 minus 10j it will come on the right hand side as it is, no change. Now we will become, push this on the underneath, that is 4 minus j10 on the top, 5 at an angle 75. 50 at an angle 75 divided by, convert this into phasor, polar form, that is 10.77 at an angle minus 68. Now 50 divided by 10.77, it is nothing but 4.647. 642. Now 5 will become 75 minus half minus 68.2. So 75 plus 68, it become 143. So now convert this into again in the sinusoid. 4.624 is as it is here. Now cos 2t, because already given here 2t omega. Now angle is 143. So put the angle here 143.2. So this is the steady state solution. Now our actual study will start here. Yeah. So phasor relationship for resistor, how it will be. Now that we know how to represent voltage or current in the phasor or frequency. Voltage in cosine form and current also in cosine form in the frequency and time domain we studied. Now we have to relate. One may ask how to apply these circuits involving passive elements RLC, resistance, inductance and capacitance, when in the circuit, how this voltage and current will be related with the resistance, inductance and capacitance. So we know what is the resistance in general form. It is the AC voltage instantaneous. V is equal to cos omega t, Vm cos omega t plus phi. I is equal to Im cos omega t plus phi will be there. So, and generally Ohm's law, V is equal to IR, we know it. Now coming to here, if you transform into the phasor, this V will become capital V and this I become capital I, resistance will be as it is, where Ohm's law will be V is equal to capital I and R. Now what is V here, what is I here, we have to find. V generally Vm at an angle phi. What is I? Im at an angle phi. That we will prove here. So relationship of resistor. If the current through the resistor R is I equal to Im cos omega t plus phi, it is given. Im cos omega t plus phi is there. Now the voltage across, it is given by the Ohm's law. What is the voltage across? It is V is equal to IR. What is Ohm's law? V is equal to I multiplied by R. So directly we can write V is equal to IR. What is I? It is nothing but Im cos omega t plus phi. Now this Im cos omega t plus phi, how I can write? Capital I at an angle phi degrees. The phasor form of the voltage V can be written as capital V at an angle phi. V is equal to R Im. This R Im at an angle phi you can write, because Im cos omega t plus phi in the phasor form I can write as a Im at an angle phi. So this is your capital V. So like this in the phasor form. This is in which form? Sinusoid form. This is in the phasor form. So that's why. Now what is Im at an angle phi? I can write as a capital I. So that is also in the phasor form. So that's why you are writing here V capital is equal to capital I multiplied by R. R is the normal resistance, not changing. So like this, but the phasor representation of I capital I is nothing but Im phi. So this I am rearranging with Im phi at an angle with the capital I. So V is equal to IR, which is satisfying the Ohm's law. Now V is equal to Ri, R, IR, both are same. Now you can see the relationship here. This is the real part, this is the imaginary part. Now we know what is I here? Im cos omega t plus phi. So Im cos omega t. What is Im? Inside this vector. So Im is there. What is the phi? How much? This much phi. It is the plus. Plus means anti-clockwise, upwards. Plus phi. Minus means downwards. So this is plus phi. So that is I. Now what is the voltage here? It's nothing but multiplied by R. This is also same at an angle phi only. It's not changing. It's not adding with 90 degrees or 45 degrees. It's not adding. It is same angle. So it is in the same vector. V will be there. Why I is here and V is more here? Because it is multiplying with the resistance some quantity. Resistance may be 4, 5, 10, something. If something is multiplied with the current, it will be more than that value. So I is up to here, 0 to I up to here, length. Now from I to V is nothing but R multiplied by I. Is nothing but your V. That's the multiplication factor R. So that's why more value here. V is top and I is in the down. So like this. So what you observe here, both are in phase. Means I and V in the same line. I and V is not differentiating, not moving either left or right. Okay, down or up, it's not moving. So both are in the same line. It is called in phase. In phase means in the same alignment. There is no difference in the angle between voltage and current. That is called in phase. The voltage and current are in phase as illustrated in the figure. Now this is about the resistance. Now go for the inductance and then go for the capacitance. Now next go for the inductance. If the current through an inductor L is I equal to Im cos omega t plus phi, same current. Previously also I is equal to Im cos omega t plus phi for resistance. Same I am taking I equal to Im cos omega t plus phi. Now what is the voltage? What is the basic equation of voltage across the inductor? Basic equation in terms of Ohm's law. V is equal to, inductor is there, L is there, proportionality constant L is there. What is the Ohm's law for the passive element of inductor? V is equal to in terms of I. Ohm's law is V is equal to IR. We know for resistor. What is Ohm's law for inductor? V is equal to L di by dt. Rate of change of current is nothing but your voltage. Rate of change of current is nothing but your voltage. No, class. So V is equal to L di by dt. Remember that one. V is equal to L di by dt is equal to, so differentiate this Im cos omega t plus phi. So when you differentiate cos omega t, it become minus sine. Now omega t, it become how much? Omega will come out. So minus omega L Im. The L is already there. Im is there already. So L Im multiplied by omega, which is coming out from the cos term. Now cos will become sine omega t plus phi as it is. Now this is your differentiation. Now I told you, whenever there is a sine term in the cosine format, sinusoid, in the sinusoid format, whenever sine term is there, we have to convert it into cos term. Both voltage and current should be in the cosine, not in the sine. Okay, sinusoid, not in the sine term. So convert this sine term into the cosine. How we can convert this sine into the cosine? If you want to convert this sine into the cos term, we have to add here plus 90 degrees, lag, plus 90 degrees, right? When we convert the sine term into the cosine term, then we have to add plus 90 degrees, cos plus 90 degrees. It is nothing but your cosine term. Okay, so now it is okay. We can write here sine as a cos omega t plus phi plus 90 degrees. But the problem is there is a minus sign outside that has to be taken care. That has to be positive term. So that minus, when you go inside, this plus 90 will become minus 90. Okay. So minus sin A, just how it will be. Minus sin A is nothing but cos A plus 90 degrees. So minus of minus, it become plus. So it is cos A plus 90 degrees will be coming here. So minus sin A will be coming, cos A plus 90 degrees will come. Generally, only sin is there, then it become cos minus 90 degrees will come. But here minus is there, when go inside, it become minus of minus, it become plus. So we can write this sine of minus sin omega t plus phi as cos omega t plus 90 degrees. Cos omega t plus phi plus 90 degrees. Because of this minus term, it become minus of minus plus. So this voltage of this equation will become omega L Im. This sine will become cos omega t plus phi plus 90 degrees. So now it is in the same format. Im cos omega t, Im cos omega t in the same format. Okay, now convert this into phasor. How we will convert this into phasor? I can rearrange this cos omega t plus phi plus 90 degrees with e power in exponential form, e power j phi plus 90 degrees. E power of j phi plus 90 degrees. Because of this cos, I put e power of j, because cos always is a imaginary part of this equation, right? That's why I put e power of j here. So now omega L Im as it is in the previous case, what it is there. Now I am converting this into phasor. Cos omega t plus phi plus 90. Cos omega, how can we convert it into phasor? It is e power of j omega t plus phi plus 90 degrees. Okay. So now e power of j plus phi plus 90 degrees. I rearrange this in two different form, that is multiplication. E power of j phi, e power of j 90. Separate this plus in the multiplication. E power of j phi, e power of j 90. Now these two are the multiplication. Now e power of j 90. What is e power of j 90? Or we can come to this one later. Now I can write this equation as Im e power of j 5 and j 90 can be written as 5 plus 90 here. Im j small im 5 plus at an angle 90 degrees in the polar form. This is in which form? Exponential form. Now I am writing this in the polar form, 5 plus 90 degrees. Now I want to rearrange this one, these two. How we can go? Omega L Im and the phase angle is 5 plus 90 degrees. Now I want to rearrange this. Im at an angle phi. Im at an angle phi is nothing but Im at an angle phi is nothing but capital I. Now e power of j90 in this e power of j90 I can write as j. E power of j90 I can write as j. So what happens here? E power of e power of j90 I can write j. So that's why the j will come out. So j omega L Im e power of j5 will be remain. So the Im j e power of j5 is nothing but your capital I. So it is j is coming out. J omega Li is your resultant from this equation. So see here, Im j5 is nothing but Im e power of j5 is nothing but capital I. Now what is e power j90? It is j. Okay. So j omega L capital I is your voltage. Now previously resistance. What is the equation? Resistance V is equal to capital I capital R. Capital I R. But here what is the equation? V is equal to, it should be L and I should be there, capital I. But L is having some extra term j omega. J omega is the term which is having with the L in the Ohm's law. But in the Ohm's law for the resistance, it is purely R into multiplied by I. But here extra term is coming, j omega, imaginary term we call that generally. It is an imaginary term, j omega is coming here with multiplication with the L. Okay, same it will come in the capacitance also, but in different form. J omega term always will come. Okay. See here how we will represent. It is V is equal to L di by dt in the sinusoid form. Now in the phasor form, V is equal to j omega Li. J omega is the extra term. It is coming because of di by dt. Now recall your previous classes. Di by dt. D by dt always written in phasor form like j omega. You can rearrange. No need to do these all equations here. Differentiate, convert and rearrange. No need. You just know what is d by dt in the phasor form. What is d by dt in the phasor form? It is j omega. Directly you can put, no problem. Same. Integration. Integration is 1 by j omega. This is differentiation. D by dt is j omega in phasor. Integral dt is 1 by j omega in the phasor form. So that you have to remember. These two is important for inductance and capacitance. Inductance always have d by dt. That is j omega will come. Integration will come for capacitance. That is 1 by j omega will come. Okay, 1 by j omega will come. We'll see that one. The voltage and current 90 degrees out of phase. Now check here j omega. What is the j omega term? It is 90 degrees. J 90. So it is 90 degrees out of phase. How much? Especially current lags the voltage by 90 degrees because it is plus 90. Plus 90 means what? It is lagging. Okay. So check here. Sorry, plus 90 means it is leading. What is leading here? Plus 90? Voltage. Voltage is leading the current. So rearrange this sentence. Voltage leading 90 degrees with current. Rearrange opposite. What we tell? Current is lagging the voltage 90 degrees. I told you both form is correct. If you tell about lag and lead, one should be reference, one should be the other opponent. So reference is leads the opponent. Then opposite, what we'll say? The opponent lags the reference. So that's why here plus 90 means leading. The voltage is leading the current 90 degrees because plus 90. If you rearrange, it becomes minus 90. That tells current lags the voltage. It becomes as a minus 90. So see here. Actually I is the given. I is the given. Cos omega t plus phi. 5 degrees. Okay. Now voltage, how much it is moving? Plus 90. Right? It is moving backwards. Moving backward. Plus 90. Anti-clockwise always. So before the current, voltage is coming. The voltage is coming before the current. So I always lags the voltage for inductor. It is quite opposite to the capacitor, we'll see. So voltage current relationship for the inductor. Okay, now coming to the capacitor. Capacitor, what is that? The voltage across the capacitor is V equal to Vm cos omega t plus phi. The current given by, now here I am giving V, Vm cos omega t. Now I want the current. So how can I write this Vm cos omega t plus phi? What is the current generally in capacitor? What is a capacitor? In Ohm's law, as per the Ohm's law, current as per in the capacitor I is equal to 1 by C integral V dt. Okay, good point. 1 by C integral V dt. So what is integral dt in as per phasor? 1 by j omega. D by dt in the phasor, differentiation, d by dt in the phasor, j omega. Integral dt, what is in the phasor? 1 by j omega. So already 1 by c is there. Now it is 1 by j omega c multiplied by v will become. So c I equal to c dv by dt also we can go. I we are finding I is equal to c dv by dt. Now rearrange this function. I take this side. Voltage will become integral of I dt. So it become 1 by c j omega, 1 by I by j omega c, 1 by c j multiplied by j omega will be there in the down. So v is equal to, we are finding v here. So it will go integral I dt and 1 by c. So integral is nothing but 1 by j omega c and capital I is coming here. Okay, now the current and voltage is 90 degrees out of phase. 1 by j, what is 1 by j? Minus 90. What is j omega? Plus 90. What is 1 by j omega? It is minus 90. 1 by j is nothing but what? Minus j. 1 by j is equal to minus j. So j is nothing but 90. So plus 90, now it becoming minus 90. Okay, see the phasor diagram here. First voltage is given here. Voltage is given here at an angle phi. With this voltage, what we found? 1 by j we found. So it is here angle. So minus 90 degrees. Voltage now here leads the current. So previously voltage, what's happening there? Current is given, voltage is leads the current. But here what is voltage is lags the current. Voltage is after current it is coming. So voltage lags 90 degrees with the current here. Just rearrange. This V there in the inductance was I and I in the inductance was V. So just opposite is there. 90 degrees. Here V is coming first. In the previous slide, I was coming first. So voltage is lagging the current I. There voltage is leading the current I. That's the difference. So this is how capacitance. Now these are equations are there. Better to if you don't want to remember the how to derive, just I want to by heart. Then one table I gave. Check it here. I summarized here. So first element, what are the elements we have? Resistance, capacitance, inductance. Now what is the equation in the time domain? What is the equation in the frequency domain? We'll see. First one, resistance as per the Ohm's law only. V is equal to IR, that is RI. And here in frequency domain, V is equal to RI, where V is nothing but Vm at an angle phi. What is I? Im at an angle phi. That is the phasor. Now coming to the inductance, we know V is equal to L di by dt as per the time domain. V is equal to L di by dt. Now change this di by dt into j omega. So capital V is equal to j omega L I. I is becoming capital I and this d by dt will become j omega. So V is equal to j omega L I. Okay. Now capacitance. We know I is equal to C dV by dt, but I want in terms of V only. So change this C this side, that is 1 by C I integral dt. So what happens? One integral V is nothing but capital V and this side 1 by C is there. So 1 by C is there. Now I integral of I dt is nothing but 1 by j omega and I will become capital I. So this is V is equal to I by j omega C and here V is equal to j omega Li and here V is equal to Ri. These three you have to remember for any time. This is okay, direct resistance always same. In the DC circuit, in the AC circuit, both are same. But in AC circuit, we have V is equal to j omega Li. Remember, it is Ohm's law will be j omega Li. And V is equal to I by j omega C as per the Ohm's law. Okay, because it is in frequency domain. So we can see relate for DC. When DC is there, what is the frequency? Good, very good point. Very good point. Frequency is 0 for DC. And I told in DC, inductance will behave like as dash. Short circuit or open circuit? Good. Short circuit. It will behave as a short circuit. Capacitance will behave as open circuit because it's two plates are there. In between, nothing will come. So, how it will be proved with this equation? We'll see. What is omega in terms of frequency? 90. No. Omega equal to, it is frequency equation omega. Omega, actually time period T is equal to 2 pi by omega. Remember in the previous slide, time period T is equal to 2 pi by omega. What is time period in frequency? 1 by F. 1 by F is equal to 2 pi by omega. So omega is equal to 2 pi F. Omega is nothing but 2 pi F. Now, for DC, here omega is nothing but 2 pi F. Here, what is omega here? 2 pi frequency F. Now, frequency, how much for DC? 0. Frequency for DC circuit is 0. So, 2 pi multiplied by 0 here. How much? Kullu? 0. So, voltage is 0. Means what? Short circuit. There is no voltage drop. Means short circuit. Inductance will act as a, how? In DC circuit, inductance will act as a short circuit, right? How we are proving? Here, j omega. Omega is nothing but 2 pi F. F is frequency, 0. So, 0 multiplied by something, 0 only. So, voltage is 0 means there is no voltage drop there. It is act as a short circuit. Now, coming to here, I by j omega C. 1 by j omega. Omega is 2 pi. 2 pi F. F is 0. Something by 0. What is? Infinity. Something by 0 is infinity. So, infinity means what? Open circuit. Means very high voltage, infinity voltage. So it acts as an open circuit. So how, like this we will prove here in AC to DC relation. You can remember like this also. Okay, now coming to the phasor relationship for circuits examples. One we have, okay, another 20 minutes we have, 10 minutes. One we have the voltage V is equal to 12 cos 60 t plus 45 degrees is applied to 0.1 henries. Now we need a steady state, what we need? Steady state current. Current we need. V is given. What is the current? I is equal to. Yeah, either you can use the derivative formula or you can use direct formula also, up to you. First convert this into phasor. V is equal to 12 cos 60 t plus 45 degrees. Convert this into phasor. V, it is nothing but Vm at an angle 45 degrees. Vm at an angle phi. So it become 12 at an angle 45 degrees is nothing but your capital V. Capital V is nothing but Vm at an angle phi. So what is Vm? 12. Phi is nothing but 45. This is capital V. Now what is L? 0.1 henries. L is known. So what is the equation? Current I equal to, as per Ohm's law in inductance passive circuit, I is equal to j omega Li. Right? What is the inductance equation? Previous slide. Check the previous slide. Remember this. What is V? J omega Li. Right? What I need? I we need. Right? So what is the equation? I equal to V divided by J omega L. V taqsim J omega L. So we know what is V. We know what is L. 0.1 henries. We must know what is omega. What is omega? Omega is nothing but 60 omega t sine or cos omega t plus phi. So omega is 60. So directly substitute. Omega is 60. And we write this V in terms of capital V, 12 at an angle 45 degrees. So what is current I? V divided by J omega L. Substitute omega 60 and L as 0.1 and V in terms of polar form 12 at an angle 45 degrees. J is as it is, omega is 60 and multiplied by 0.1. 60 multiplied by 0.1, 6. Now what is J actually in terms of phasor? 90 degrees. J is nothing but 90 degrees. So 6 at an angle of 90 degrees. So divide 12 by 6, it is 2 at an 45 minus 90 because it is division. Division is 5 1 minus 5 2. Multiplication 5 1 plus 5 2. So 5 1 is 45 minus 90. So it is minus 45. So this is current actual is given in phasor is 2 at an angle 45. Now convert this into sinusoid. How will convert this into sinusoid? Vm cos omega t plus phi. So Vm is 2, that is 2 cos omega t, that is 60t, that is 60 is there, 60t minus 45. See here. Converting this into time domain. So Vm is 2, that is 2 cos omega t, that is 60t minus, or that is plus 5 is there. So what is phi here? Minus 45. So this is your current. What is the voltage? Voltage is 12 cos 60t plus 45. What is the current? 2 cos 60t minus 45. Now tell me the phase difference between voltage and current. It is plus 45, it is minus 45. What is the difference between voltage and current here? How much? Here phi 1 is plus 45. Phi 2 is minus 45. So what is the difference between V and I? 19 degrees. How? Some may confuse. Sir, 40, plus 45 and minus 45. It is 0. No. How the phase difference is calculated? Phi 1 minus phi 2. Not phi 1 plus phi 2. Phase difference is first phase minus the second phase. This is the difference. Difference. Difference means what? Negation. Right? Difference. Difference between phi and phi 2 is what? Phi 1 minus phi 2. So phi 1 is 45. Minus phi 2. So minus of minus plus here because it is minus 45. So 45 plus 45 come to 90 degrees. So what is the phase difference between I1 V and I? Plus 90 degrees. So it is lagging. Plus 90 is lagging. Just check. Okay. Now another example, we will close this. Impedance. Okay. Next class we'll finish the impedance, admittance. No problem. So this is how we'll finish this one. Okay, our next topic is impedance. Before going to impedance, just recall our old topics in this chapter, that is chapter 6. So we studied about the sinusoid, we studied about the phasors, and we related these sinusoids and phasors for voltage and current. Then we related these to resistance, inductance, and capacitance in time domain and frequency domain. The time domain is nothing but your sinusoid. Frequency domain is nothing but your phasor. So just check what is the resistance. V is equal to Ri. This is instantaneous value of time domain V and I. R is a resistance. Now here frequency domain V, capital V is equal to R capital I, where V is the phasor form of this time domain V and I is the phasor domain of this time domain current. So we know what is V capital V and what is capital I. V is nothing but in this instantaneous value Vm cos omega t plus phi, we will take Vm at an angle phi. Same I will take Im at an angle phi. Same if we go for the inductance, it is, we know that V is equal to L di by dt, because in time domain we have cosine term, sine term, so we have to differentiate for getting the voltage if we have inductance L di by dt. But this will omit in the frequency domain, that is phasor. It is directly V is equal to j omega Li. J omega is the, J is nothing but your imaginary part, omega is the radians per second, and inductance you already know, I is Im phi. Im at an angle phi. So just remember this j omega is extra term in Ohm's law for V is equal to IR term. Here V is equal to IL, but j omega will come because it is a inductance and it act as a imaginary part. Same capacitance also act as imaginary part. I is equal to C dV by dt. But here differentiation is for voltage, here differentiation is for current, for inductance. But if you rearrange this, differentiate and rearrange in terms of voltage only for frequency domain, that is phasor, then it will be I divided by j omega C. The easy concept to understand, V is equal to IR is Ohm's law. For inductance, V is equal to j omega L will be there, extra part j omega L I. Now for capacitance, I divided by j omega C. It is 1 by C usually come. It is 1 by j omega C will come. So this you remember for the next topic for impedance and admittance, impedance and admittance. Let's see. So this is example already discussed. Now go to impedance. What is impedance? In the previous section, we obtained the voltage current relationship for three passive elements, that is resistance, inductance, and capacitance. That is V is equal to Ri, V is equal to J omega Li, V is equal to I by J omega C. Just now I discussed. Now these equations may be written in terms of the ratio of phasor voltage to the phasor current. Ratio of the phasor voltage to the phasor current. That is R is nothing but V divided by I. L is nothing but V divided by or j omega L is nothing but V divided by I. J omega C is nothing but I by V. Like this we can represent in the phasor form. So R is V by I, J omega L is V by I. 1 by j omega C is also V by A. So this is the phasor differentiation division with the voltage to the current. From these three expressions, we obtain Ohm's law in the phasor form for any type of element. So that's what I discussed. These are now Ohm's law now. V and I relationship for resistance and inductance and capacitance. So Z now we call V by I, V by I as Z. So this now it is Z. Z is nothing but your impedance. So V is equal to Zi. Ohm's law. Okay, separately we defined here Ohm's law method. Now we define a combined. If R, L, C all are present in the circuit, then how the Ohm's law will come together, because resistance pure is not possible. Inductance pure inductance is not possible. Capacitance pure capacitance is not possible. So that's why we need a combination of all three for having an Ohm's law. So that is nothing but V divided by I is equal to Z. That Z is called as an impedance, where it includes all R, L, C items in future, inshallah. So where Z is the frequency dependent quantity known as impedance measured in ohms. So you cannot say Z as a useful for DC. This is frequency dependent. It means when frequency is not zero, then only Z can be generated. If frequency is zero, then Z will purely become resistance R. Okay. So if we have a frequency other than zero, any type, any quantity, then Z will generate, and that is known as impedance measured in ohms. The definition you have to remember: Z is a frequency dependent quantity known as impedance measured in ohms. The impedance Z of the circuit is the ratio of the phasor voltage V to the phasor current I. So the impedance, the definition, another definition. The impedance of a circuit is the ratio of the phasor voltage V to the phasor current I measured in ohms. So now here the logic is V if in phasor always with a frequency, I in a phasor always with a frequency. Okay. Okay, now as a complex quantity, the impedance may be expressed in rectangular form. So impedance should, if we are expressing in the rectangular form, how it will be. So phasor means three items you have to come in mind. What are the three items you have to come into mind? Rectangular and polar and exponential. So first we will express this phasor of the impedance in rectangular. So Z is always can be written as R plus JX. R is the resistance and X is having a imaginary part which includes capacitance and inductance both. Let's see. Where R is the resistance and X is the imaginary part of the Z, which is known as reactance, which includes inductance and capacitance. The reactance X may be positive or negative. When it is positive, what it behaves, and when it is negative, what it is known. We'll see. We say that the impedance is inductive, that is when it is having an inductance, then X is positive. If this is a positive, then we call it that circuit having a inductive circuit or dominant in inductance, or capacitive circuit if it is a negative. Here if minus sign is there, R minus JX, then it will we can tell it is a capacitive or dominant circuit, or capacitive circuit also we can say. So thus impedance Z is equal to R plus JX is said to be inductive, or when it is inductive, lagging. Current is lag, since the current lags voltage, lagging circuit. Inductive means lagging, What is lagging is reference is current. So the current lags, current lagging the voltage, while the impedance is capacitive or leading, because current leads the voltage. So here reference is actually voltage, but how the current will behave. So current will lags when it is inductive, and current will leads when it is a capacitive, we can say. The impedance, resistance, and reactance all are measured in ohms. So by ohms law here it is satisfying in phasor form. So all will measured in ohms only. Actually, inductance is measured in Henry and capacitance measured in farads. But we converted that into phasor form of a reactance. So the impedance, resistance, and reactance all measured in ohms. Okay, you have a doubt that resistance, okay, it is purely resistance, so it is ohms. But impedance, reactance is having a inductive, that is inductance, and a capacitive, that is a capacitance is there. How it is in ohms? No, we are converting this into in the form of reactance. That is it's part of, like a resistance only. It's part of resistance by multiplying with j omega L or multiplying with j omega C. So it is converting into reactance from the inductance to the capacitance. So that's why it is in ohms. The impedance may also be expressed in polar form as Z at an angle theta. So I told you three format: polar, rectangular, and exponential. So exponential is not that much needed here. Mostly polar and rectangular is practiced for impedance and admittance. We'll see the admittance later. So Z I can write as at an angle theta. What is Z? Comparing the equation, Z is nothing but R plus JX, and this is nothing but Z at an angle theta. What is Z? If you find, it is square root of R square plus X square. Then theta is tan inverse of X divided by R. So Z is nothing under root of R square plus X square from this rectangular. Now the angle theta is nothing but tan inverse of X divided by R. Whatever angle it will come, it will can be written here. Now if we have only R and theta, sorry, Z and theta, if we have polar form, if we have a polar form, I want to write what is X and R, then what can write? R is equal to, because generally sometimes it is given polar form, right? Then you have to convert into rectangular form. You must know what are the equation. When it is in polar form, how to convert? Then it is Z cos theta is the first term, real part, that is R, and Z sin theta modulus. What you call sine, you have to take minus or plus. Just you take plus term only. Magnitude you have to take, not the sine term plus minus. That is the mod. Mod it is. So mod that is Z cos theta mod Z sin theta is X. Z cos theta is R. Now directly you can write R plus JX in rectangular form. So you must know both the transformation, that is from rectangular to polar. It is Z is nothing but R square plus X square whole under root. Theta is nothing but tan inverse X by R. Now once you know this polar and it is given, then convert to back to the rectangular is R is equal to Z cos theta, Z must be modulus, X is nothing but Z sin theta, Z must be modulus. Now check here what happens at high frequencies. Now inductance, what is the equation for inductive reactance? J omega L, it is the J omega L. So what is J omega? Omega, what is the equation? Omega is nothing but your, in terms of frequency. When it will, in terms of frequency, for high frequencies, how it will act as inductance? For high frequencies, equivalent circuit for DC and high frequencies. For DC, it is F is equal to 0. So it will act as a J omega C. What is the equation of omega here? 2 pi. Actually, omega is nothing but 2 pi by omega is 2 pi by omega is nothing but T. So T is 1 by F. F is what is the F? We can see that in previous equation. Reactance is here 2 pi F. Omega is equal to 2 pi F here. So if the frequency is 0, omega will be 0. Then what happens? Voltage will be 0, V is equal to I j omega L. So what happens for DC? It will act as a voltage is 0 means short circuit. Now if frequency is high of 2 pi f, omega is equal to 2 pi f, very high frequencies, what happens? Voltage is very high. When the voltage is very high, when it is act as an open circuit. Okay, for high frequencies it will act as open circuit. For zero frequency it will act as a short circuit. It's quite opposite to the capacitance. Capacitance we have C is equal 1 by 2 pi f I by 2. It is generally V is equal to current divided by 2 pi f C, that is omega j omega C. So I by j 2 pi f C. So now frequency when it is 0 for DC circuit, generally something by 0, it is infinite, so it is open circuit. Now for high frequencies, in the division high, very high frequency means the complete value voltage is 0, so it is short circuit. So like this, for low frequency, that is not low frequency, it is equal to 0. When frequency is 0, inductance act as a DC. When frequency is 0, the capacitance act as a open circuit. But for high frequency, inductance act as a open circuit and capacitance act as a short circuit for high frequencies. This you have to vice versa, you have to remember. So next, what is admittance? Then we'll go for the problems. So admittance. It is sometimes convenient to work with the reciprocal of impedance. We know that what is conductance? Resistance we know R. What is the conductance? 1 by R, right? So here admittance is the reciprocal of impedance. It is not exactly 1 by Z, but we will see how it is. It is a reciprocal, okay. It is 1 by Z, it is this one admittance. But how the equation will change, we will see. Known as so it's sometimes convenient to work with the reciprocal of impedance known as admittance. See, inverse of the impedance is nothing but admittance. The admittance is denoted with capital Y, impedance is denoted with capital Z. So the admittance capital Y is reciprocal of impedance measured in Siemens, measured in the Siemens, and the admittance of the element or a circuit is the ratio of a phasor current through it to the phasor voltage across it. So previously the impedance, what is the ratio? It is a ratio of the phasor voltage to the current, but here admittance is phasor current to the voltage. So this is only reciprocal. So Y is equal to 1 by Z, that is I by V, but Z we know V by I, so it becomes I by V. Okay, the admittance of a resistor, inductor and capacitor can be obtained from the previous equation 9.3 table. It's there, you can check the table. Now here, check here. So element impedance and admittance is there. R can be Z is equal to R, we know. Y is equal to 1 by R if only resistance is there. Now, if we have inductance, Z is j omega L, we know only in the pure inductance I am talking about. Then Z is equal to j omega L, then Y become 1 by j omega L. Now, capacitance is reverse. Z is 1 by j omega C and Y is j omega C. Okay, these all are pure form of the resistance, inductance and capacitance. Now, a complex quantity we may write Y as Y is equal to G plus JB, where G is nothing but your conductance, what we studied in the chapter 2, I think. So resistance is reciprocal, conductance G. Now here B is the reciprocal of your reactance. Okay, reactance X. 1 by X is your this one susceptance, we can say. B is your susceptance and G is your conductance, already we know. So G is called conductance and B is called susceptance. Susceptance is nothing but reciprocal of your reactance 1 by X. Admittance, conductance and susceptance are all expressed in units of Siemens. All are in Siemens and mho. That is ohms is the reverse, that is impedance. Now reverse of ohms, it is mho, MHOS. Generally we call it as Siemens. Okay, from the above equations we can find G plus JB is equal to 1 by R plus JX. So we can write 1 by R plus JX, G plus JB, because G plus JB is nothing but your capital Y, that is your admittance, and capital Y is nothing but 1 by capital Z, that is your impedance. So by rationalize, now rationalize this one, I want to take out this j factor in the denominator. I want only in the top. So multiply and divide with r minus jx. Multiply and divide with r minus jx to this one plus jx. So what happens? This will become r square minus r square plus x square will become in the multiplication. In the top it will be r minus jx. So g plus jb, the format g plus jb can be written as r minus jx divided by r square plus x square in terms of resistance and the reactance. So this g can be written directly as g is equal to r by r square plus x square, and b can be written as minus x divided by r square plus x square. Okay, so this is the G for part in terms of resistance and reactance, and B part in terms of resistance and reactance. So minus will become here x divided by r square plus x square. So we can know directly tell that, showing that conductance G is not equal to 1 by R as in the resistive circuit. Generally G in the resistive circuit with DC, that is 1 by R, but in, don't make mistake, in the AC circuits where reactance is there, inductance and capacitance, then it is directly 1 by R. You cannot substitute here. It is nothing but G is nothing but R divided by R square plus X square. It will is related with the other parts also. Okay, if X is equal to 0, it is now, if let us take there is no inductance and capacitance, then B term will be 0. That is X term will be 0. Then X term is 0. R by R square is nothing but your R only. That is 1 by R only. So like this you can remember. Now coming to the example problem, then we'll finish our chapter 6. So find V of t and I of t in the circuit. We need the voltage and current for the circuit in the figure, where we want in the capacitor. Where is V here? V of t, I of t, I want in the capacitor. What is the voltage and what is the current? Already given source voltage 10 cos 4t, resistance is given 5 ohms, and capacitance is 0.1 farads. From the voltage source 10 cos 4t and having a omega is 4, that is from this equation 4 is the omega, directly we can say. And how we can write this in terms of phasor? Vs is equal to, this is the Vm 10 at an angle 0, because it is 10 cos 4t plus 5 should be there. 5 is not there, it means it is a 0. So it is 10 at an angle 0 degrees. Easy to for calculation. Now impedance, how the impedance will be? Resistance and reactance is there. First one R plus jx, but here capacitance is there. So you can see here 5 plus 1 by j omega c you have to write, because this capacitance is R plus jx, R plus jx. What is x here? So 5 plus j omega c, 5 plus 1 by j omega c we have to write. What is the reactance? So 1 by j omega c we can write here as j omega, that is 4, and 0.1, this is your capacitance, then it will become 0.4. 1 by 0.4 is nothing but 2.5, but 1 by j, if you rearrange this one in this equation, it is minus j. If j is going on the numerator, it will become minus j. So it is 5 minus j 2.5. Now you can observe this equation, 5 minus is there, minus j 2.5 is there. So minus means capacitance. Previously we add as a normal, 5 plus 5 is resistance plus some reactance. So what is the reactance? We substituted the equation, then the result is coming, this plus is becoming minus, means it is a capacitance. So it is a capacitive circuit, we can say, by observing this minus term here. Okay, so hence the current. So we got the Z. The current is nothing but I is equal to source voltage Vs divided by in phasor divided by impedance Z. So what is Vs? Already we have 10 at an angle 0. What is Z? We got in rectangular form 5 minus j 2.5. So one is in polar, one is rectangular. So we can do one thing, easy for calculation. Convert this into polar form, 5 minus j5. Then you can directly divide and these angles can be negated. Or we can do rationalization, that is 5 minus j 2.5. You can multiply and divide on the top and bottom. So it become in the down 5 square plus 2.5 whole square. So it is 25, it will be here, something will be there. So 10 divided by you can find easily. So this is also another method, not a big deal. Now here in this rectangular form, it become 1.6 and j 0.8. Now convert this rectangular form into polar form. It will coming 1.789, 26.57 degrees it is coming. My method, another method of what I told you, convert this z into polar form. Directly you can divide so that you will get direct answer this. No need of again doing this one. Okay, so this is your result. So the voltage, now we got current, we got impedance. Now we need a voltage V at a capacitor. So V is nothing but, here is nothing but current multiplied by the reactance of this capacitance. Okay, that is V is at a capacitor is nothing but IZC. So what is IZC? ZC is nothing but 1 by j omega c. 1 by j omega c. I is as it is because I already we calculated. So 1 by j omega c. Substitute what is I? 1.789 at an angle 26.57 divided by j omega c. Omega is 4 and c is 0.1. So if you calculate, you will get 0.4 at a j omega. What is j is nothing but in polar form 90 degrees. J is nothing but in polar form it is 90 degrees. So 4 into 0.1, 0.4, j is 90 degrees. So when you divide this 1.789 by 0.4, 4.47. Now these angles should be negated, 26.57 minus 90, because it is going up in the division rule, phi 1 minus phi 2 when it is division. So it is minus 63.43. So this also tells why it is minus is there voltage here. You can say it is a capacitance. Current is reference positive and voltage is this one negative. So voltage is lagging the current, we can say here, or we can say current is leading the voltage, we can say, because minus 63. Okay, converting I and V in the equation to obtain time domain. So convert this into time domain. I of t is nothing but this I if you come in time domain, 1.789 is in the time domain in terms of like cosine sinusoid. Then 1.789 will be there, 1.789 cos 4t plus 26.57, this one 26.57. Now voltage will become V of t, that is Vm 4.47 Vm cos 4t minus 63.47. Now from this you can observe current is positive angle and voltage is a negative. So which is more positive? So this is current is leading the voltage. So current I leads the voltage by 90 degrees as expected. You can subtract this one. That is phi 1 phi 1 minus phi 2 we can say. That is 26.57 minus 63.43. It is exactly 90 degrees. But here the reference is I. So voltage is coming negative. So voltage is coming negative means voltage is lagging the current. So vice versa, current is leading the voltage, we can say. So this is how we have completed our chapter 6. We studied sinusoid, and we studied phasor, we studied relation for resistance, inductance and capacitance with voltage and current in terms of phasor and sinusoid. Then we studied impedance and then admittance. This is a quite big chapter, but we have to practice, then we will get easy, and this will be useful for other subjects in the future. So you just get a summary. A sinusoid is a signal in the form of a sine or cosine function. It has the general form V of t. This is equal to Vm cos omega t plus phi. This is sinusoid. Now phasor form, where Vm is the amplitude, omega is 2 pi f in the terms of frequency, angular frequency, and omega t plus phi is the argument of the cosine term, and phi is the phase. So this already we studied. A phasor, now coming to phasor. A phasor is a complex quantity because it may have a rectangular polar exponential form. A phasor is a complex quantity that represents both the magnitude and phase of the sinusoid. So phase and magnitude will be represent. Given the sinusoid V of t is equal to Vm cos omega t plus phi, its phasor V is. So if Vm cos omega t in the sinusoid is given, then its conversion to the phasor is V, capital V will denote as a phasor, which is equal to V maximum, that is V maximum amplitude of that sinusoid at an angle phi for that sinusoid. So we will represent phasor in this form. Now in AC circuits, voltage and current phasors always have a fixed relation to one another, because in AC circuit voltage and current always have a fixed value of 5 degrees. So then if V of t at a particular time, if Vm cos omega t plus phi V is there for voltage, let us take voltage angle, let us take, represent the voltage through the element, and I of t is equal to Im cos omega t plus phi I, where phi V is the voltage angle and phi I is the current angle. Then represents the current through the element. Then phi I equal to phi V if the element is a resistor. Phi I and phi V both are the same at the same phase. It means we call in phase. Sometimes if it is 0, both are equal and 0, then pure resistive circuit. And if it is having some angle, also resistance is there, but capacitance, inductance, how much we don't know, we have to check. So if it is having 30 degrees or 20 degrees, but phi V and phi I should be same, maybe 0 or maybe other angle, then we can say the element is resistor. Phi I and phi V is same, then it is called resistor. Now phi I leads phi V. Phi I leads. Leads means what? By 90 degrees, let us take. Phi I leads the phi V, means here minus 90 degrees. Then the element is the capacitor. Phi I lags, current is lags phi V plus 90 degrees. Then it is called a inductor. Then it is a inductor, we can know. This may come in the quiz also, be careful. The impedance Z of the circuit is the ratio of the phasor voltage across it to the phasor current through it. The ratio of impedance we already know, V by I, which is equal to R omega, that is in the radians per second at the rate, and j omega in radians per second. In the what is the omega here? It is not multiplication. It is a which is called phasor. In the terms of phasor, it means. Don't confuse here. R at omega means we are not multiplying there. In terms of frequency domain, it is telling R in terms of frequency domain and X in terms of frequency domain. Okay, the admittance Y is nothing but 1 by Z, that is G at a frequency domain and B in frequency domain. G is the conductance and B is the susceptance. Here in Z, R is the resistance, X is the reactance. Impedance are combined in series or in parallel, same way as the resistance in series or parallel. So easy method, I didn't discuss this one. Now you can say impedance like a resistance in series parallel is there, impedance also can be calculated in the same way. First, you have to find what is the resistance and reactance, that is impedance R plus jx, form it first, then calculate in the same format like a resistance in series parallel. For the resistor, Z is equal to R. For an inductor, Z is equal to Jx or J omega L, which is J omega L, Jx. And for the capacitance, J is equal to minus Jx, that is 1 by J omega C, we can say. J minus Jx will come because J I am taking up. So minus Jx will be there, 1 by J omega C. Okay, these are the practice problem with answers are there. You can find it. So thank you for watching.